Alrighty, so once again, let me just introduce myself to all the new attendees here. Hi everyone, this is Srikanth Tangirala. You can just call me Sri. So thank you for joining the course today. We're doing the course on forecasting in Whitson Plus, everything concerning with the modules of DCA, auto forecast, and type wells, even group forecasting. So we're definitely going to learn a lot of things from the forecasting side on the DCA. By the way, I'm a petroleum engineering consultant located in Houston over here, our office for Whitson, and glad that you all joined this course right now. So let's get directly into the course. Hope you're all also able to see my screen. I'm sharing my slides. So just a few things on the slides. I'm just going to orient everyone, and eventually, without any wastage of time, we'll directly get into the software. So you already received an email from Jessica with our Teams link and with also a few material on the slides. You must have seen those slides there, and also your username and password. I'll definitely also be showing up the username and password once again. And where do you have to go to access the software? I think we also have included that in the chat. So you have that information over there as well. We have my team over here, my Whitson support team. Mo is over here, and sometimes Zenita is here, and Felix also here. So at times they'll also be helping me in going through the chat messages. If you have any questions, any point of time over the slides or the software, if you're getting stuck anywhere, do definitely just have a chat on the chat messenger there on the Teams, and they'll definitely do reply to you. I'll talk about a few more things of how you can just go about into the software, and if you're getting stuck anywhere, what you have to do. We'll all go through all those steps one at a time. So I think we are all excited. I'm also really excited doing this course. This is my first course I'm doing, but Whitson has been doing this for a very long time. So my objective for today is to orient all of you guys into all the functionalities that we've built in the modules for the DCA auto forecast type well. So we'll be going through every button. We'll be almost clicking every button on there on software. So just be patient whenever I'll also try to go a little slow so that everyone gets to know where exactly they need to go and they need to press. So let's directly dive into it, and we'll go a little slow so that everyone gets to see all the functionalities in. By the end of the course today, it's a 3-hour course, by the way. So we'll take a break somewhere at the midpoint. I'll let you know. And towards the end of the course, once we finish the whole thing, Jessica is going to send you the certificates. So if you just have to have some bragging rights, just put it up on LinkedIn or something to show off your manager, you have those certificates there for you. That will be provided. And if you have any concerns on editing or formatting any of those certificate things, please send an email to jessica@whitson.com. The email is being shown on the slide at the top. All right. So what we have is, if you have not seen our website, Whitson.com, let me show you all these things. We have a lot of separate whole page on the training where you go to whitson.com/training, and everything. We almost offer like about 10 to 15 of these courses this year, and they're all public in a way. And so you can either, if you're already subscribed to Whitson, you can just register to them, or you can also purchase a seat to some of these training courses. Just hit that whitson.com/training. You would see all of those that are enlisted out there. And currently today we are doing the DCA and type wells, and we have more of these courses coming in through the whole course of the year. Not just that, we have so many other learning platforms in there too. I mean, we are pretty much high on LinkedIn and YouTube. You must have already seen some of our videos in there. But if you just have to go to our Whitson channel on YouTube, Whitson Academy, and then you will see all of these webinars, a lot of webinars where a lot of our, we invite a lot of these professionals to provide some kind of a webinar, like a knowledge sharing session, or even some of the operating companies, representatives from there, they kind of pose their problems and how they have tackled those problems and those challenges using our software. We have all of those solutions in form of videos put up on YouTube. So please feel free to access and browse through all those things. And we also have those Tip Tuesday videos, which we keep posting to help you in maneuvering through the whole software functionality. So this is a great platform for you guys to just go ahead and explore. All right. So many of you people might have already seen Whitson because your company is already subscribed to it. But for those who haven't seen Whitson at all, let me just give you a brief overview of what Whitson as a software is, right? So Whitson Plus is a software that I'm talking about right now, the product. It's what we call is an all-in-one solution. It's an all-encompassing petroleum engineering tool for a petroleum enthusiast out there. So when I mean to say that, what I mean is the DCA Type Wells. When you do these workflows on auto forecast, group forecasting, which are mostly non-pressure based workflows, you can just do that where people in the reserves side of things, when they want to do all these forecasting things and building a representative type wells, you can do with using these modules. Or if you're more of a little more technical, where you're a reservoir engineer, you want to look into pressure-based workflows, understanding the well performance from the RTA side of things, we have all of those modules also in the tool. Starting off straight from the PVT initializations and calculating your BHP. Once you initialize your PVT, you get to know your viscosities, compressibilities, and densities of fluids down at different pressure temperature conditions so that you're enabled to, in fact, do your BHP calculations. And you can also do some things like flowing material balance, rate transient analyses to understand your fracture half lengths and your permeability in the matrix once you do the diagnostic plots on the RTA. And then we also have a reservoir simulation. That actual engine is built into the tool. So you're building a particular simulation for one particular well where you do history matching on the data, and also you're forecasting for that well going forward so that you know the whole EUR, the estimate ultimate recovery for the whole, and the recovery factor from a well. Not just that, these are mostly the reservoir engineering workflows, right? But we've also built in some of the production engineering workflows. So because you do the BHP calculations, you can also do a lot of nodal analysis things in there. So your IPR and VLP curves, you can understand where your operating point is, and you can also do a multi-well gas lift optimization using those modules. Besides that, even well testings, like CPG plot, DQI, Devon quantification index, the defeat curves, and everything in there, you can have this module. Once you finish all these analyses in all these modules, the best part is the comparison plot module within the software, where you can just dashboard all your results and your analyses in beautiful, beautiful plots, and just eventually export them into PNGs or Excel or even PowerPoint slides. So that is the tool in the comparison plot. It's something like a summary of all the analysis that you've done through all the modules. But okay, so this is in a nutshell what Whitson Plus as a tool is. But for today's course, as you all know, we are actually doing forecasting using the modules, which is the DCA, auto forecast, group forecasting, and then doing type wells. So just the first few of them that is boxed in the red color, that is what we're going to talk about today. Well, besides selling the software and doing consulting services, let me tell you, our main goal also as a company and everyone in the company is to set a gold standard in the industry for the response and the support tickets. So when I mean to say, what I mean is, whenever you send a support ticket to us, we are entitled and accountable to actually send a response in 2-minute response within 2 minutes, and even under 2 minutes, and at any point after those 2 minutes, once you get a reply, you're not getting a reply from a bot, by the way. These are all real people, and all those faces that you see on the slide, they are actually real employees in the company, straight from software engineers, petroleum engineers, even CEO, COO is also there on the slide. They're all, you only see happy faces on the slide, right? There's no one sad out here. We are all so passionate and so feel so responsible and accountable to accept your support tickets and to even tackle those challenges within no time. So you don't have to wait for hours and days or so, but within minutes, you will have a solution to whatever support ticket that you send to us. So that's the kind of gold standard we are trying to set within the industry. So reach out for any help, even while giving this course. You have any difficulty on the software at any point of time, like I mentioned before, just reply on the chat terminal there, and then we'll have our support team actually providing a response to you if you have any issues. I'll also go through the chat messages, and timely, I'm going to summarize a few of those questions that you have. Any point of time, you can just post them over there. And even when I take a break, I'll try to go through most of the questions and we'll summarize through the responses that we get so that everybody gets to know what exactly is the issues that people are facing. Okay. So with that, we are almost like 10 minutes mark. I think that was a good introduction, good small introduction that I've given you guys. So we are ready to dive into the software. I think before I open up any more slides or any more theoretical technical content, I'll be doing that for a very short time though, but don't worry about it. But actually, let's get excited and show up the software so that I'll provide you access, and then we'll see the whole real estate of the software itself on the web browser. Let's just do that. So for you guys to do it, what all you have to do is access this website. That's the courses.whitson.com. So go ahead, fire up your browser, and just go ahead with the courses.whitson.com, provide your username, which is the email that you registered with, and the password is on this slide right over here. It's also posted on the chat message if anybody has missed that. So I'm going to take my slide off right now, and I'm going to show my browser. So if any point of time, if you still want to have access to the password, and the username is your username that you registered with, the email address, the password is on the chat browser. Okay, so I will also do the same steps. Okay, so for me, it will look a little different. I'm sharing my screen right now, and this is the browser with the courses.whitson.com. When you log in, it'll actually ask for a prompt for a username and a password. Just hit yes, and eventually it'll take you to a screen where you're only going to look at this one particular field right now that I'm pointing. So look at my pointer. I'm pointing to this one screen which says DCA course May 2026. That will be the only one field that you'll be seeing on your end. Go ahead and click that field. So I'm just going to do that. I'll take a few breaks here and there so that I'm just letting people to also, access the software, access the tool, go through any of the difficulties they're having. Just refresh the browser at any point of time. If you're having any issues, just hit Control and R or refresh the browser. Sometimes the software, very rarely it gets stuck at any point of time, but if it does, just hit refresh on the browser. Okay, so once again, on the fields, you will not see any of the fields right now. So don't worry about how exactly it is looking on my screen. You will only see the field which says DCA course 2026. I'm basically a person within the support, so I'll be seeing all the other things on the tool. Don't worry about that. Okay. Please know, so I think there's also a question where people are asking if they can use their own company website to kind of log into it, their own company's domain. I would strongly recommend to actually use the courses.whitson.com domain because we've already registered you people. So use this and you can actually follow the same steps in this courses domain that I'm actually going to today. Okay, so once you're over here, let's go ahead. Currently, you will all see a blank screen. You'll not see any of the projects because right now what I'm seeing over here, they're all private to me because I created them. So as a next step, once you hit that DCA field, go ahead. Once you're in the project, hit the button which says Add Project. Okay, and just give it a name. I'm just giving my name and today's date. So you're just adding your project, giving a name to it. And then eventually, once you get to this point, hit the button mass upload so that we can get a few wells in and we can just play around with those wells. On the mass upload, the moment you hit that button to the top right, go ahead to the examples on the top right. Sometimes some people might not see the examples exactly placed right over there. If you're facing any of those difficulties, just go to your browser and recommended zoom in is somewhere around 70 to 80%. Maybe I'll also just move into my 80% zoom. And then once you zoom out, you will also be able to see the example section. So I'm just repeating the step once again. In the project that you created, go to mass upload, hit examples to the top right, and then use the auto forecast and type well certificate wells and just hit the button upload. You have 20 well counts, 20 wells in there in that project. Don't hit any other project, but just go with the auto forecast and type well certificate and just hit upload. It'll take a few seconds for it to load, and then you just close the browser, close the window for that particular pop-up, and then you will see your 20 wells populated in your project here, just like how you're seeing with me. So here it is, right? What I'm going to do is, let me just hit the browser, refresh in the browser. Let me see. Oh yeah, I can see all of your projects. By the way, you wouldn't be able to see any of these projects of your other people, the other registrants in this course, but you'll only be able to see just one project which you created, and that is private. So let me talk about this, right? What I will do is search for my project, and I'm just going to say edit project. And this is where, you can change the access type for the project. So either you can keep the project which is private because you created the project, so it's only private to you, nobody else will be able to see. I'm a support person, so I'll be able to see all your projects. That's a different thing, but nobody else will be able to see it. And then if you change this option to company wide, that's when you're making it accessible to everyone who's accessing this course domain, right? So that's when, if you're in a company, if it's a main project which is feeding in all the production data, then you would want to have this one project as company wide. So that is when you change that as an accessibility option. But currently, don't do this. You only just keep your own project as private. What I will do is, for my project, just going to make it company wide so that at any point of time, if people want to know what I was doing, or if you want to access my analyses in my project, you can just go into my project because that will be visible to you. So just I'm changing it to company wide. You guys can keep it private. I'm just refreshing the screen. Even you guys can refresh the screen, so you will be able to see even my project in your browser. Okay. So I hope everyone has come to this point, and you have your wells loaded. Okay, so I think everyone, I just gave a few seconds so that everyone can load their wells. I know we are loading in more than 50 or 60 of these instances of these wells at the same time. It shouldn't be a problem, but I'm just giving a few seconds so that people will have different internet speeds and things for them to be loaded. Okay, so I think we are good over here. So what I will do is I'll talk about a little real estate things on the software, show you a few of these things where the buttons are, how you organize the data, and then eventually slowly we'll go to the actual crux of the theoretical things, which is the DCA modules. Okay, so with that, let me go back to the first organization, the way we showed the fields in the initial first homepage, right? So on the left panel, what you're seeing is the way we are organizing all our modules. In fact, the first top four are basically just the way we organize those things as the data as we put into the software. So we start off with the top-down approach. We have these fields, and currently we just name these fields this way as a DCA codes. So within this field, you have multiple of the projects that are assigned over here, and these projects can have different owners. If you just click on any of those projects in there, edit the project as I was showing you. You can assign different ownerships to these projects, and you can also assign different access type to them: private, company wide, or restricted. And restricted is an access type where you are the owner. The person who's the owner has the major rights to actually do the analysis and change the analysis, but it's actually being visible to even everyone in the company, but they will only have viewing rights rather than editing rights. And the owner can actually change some of those accessibility options, and that is when the restricted things comes in, where you're giving a little more power to the owner. So it's midway between being private and being company wide. That's what is the restricted option there. Okay, so we talked about the fields, and within the fields you have these multiple projects, and within the projects you can load in any of your wells that you have. So different projects can have the same set of wells as well, but all the analyses that you do within that well is going to lie within this one project that you have. So okay, so for this project we have these 20 wells, and if I click on any of the well, it'll take me to the screen, will show me the well header information, everything related to where the well is located, what county, who's the operator, any lat long coordinates, and even some of the metadata that you see over here, the cumulative information in the initial first few days, and any of the completion metrics too. If you have that information, if you want them to load, you can also, everything can be loaded through a mass upload option. I'll be talking about that, but you'll be able to see all of these things over here on the well header information stream on the scenarios page. So basically, the scenario is also where you can create a completely different what if case analysis for your well. So when I mean to say that is, suppose you have a few of these saved cases, which you don't want to keep them public, even though the project is a company-wide project. but you don't want to share it with everyone. It's just kind of a what if case sensitivity analysis that you want to run on your own with the same production data. That's when you go to the scenarios on the top and you just say add a new scenario. All it'll do is currently it's on the main. The scenario currently is called just the main, and it's going to create a copy of the main scenario from where the analysis is a little more independent from what you saw initially in the main, so that that analysis can be kept a little more private. Let me show you, right? So right now I have this something called main. If I work on any RTA or any of the PTA stuff, and now I want to create a different interpretation, what I would do is just go here, say add a new scenario. I'll give a name to it, like a new scenario. Okay. And then you see if you scroll down your mouse to the bottom, you don't need to do this, by the way. I'm just showing you as a demonstration of what exactly is the scenario. And then at the bottom, if you scroll down, you would see that there would be the new scenario that you created would be visible. And then you can change the accessibility type for that scenario too by using the three vertical dots and change that to either private, company-wide, however you want to see. So it's like a what if case thing that you run. Okay, so let's go back to the main scenario so that we are all, if anybody has created a scenario just like me, just so that you come back to the main scenario. You don't have to do that step, by the way. It was just a small demonstration. Okay, so all the things that you're seeing on the top left, the fields, projects, wells, and scenarios, they are all placed and aligned horizontally also on the top over here. At any point of time, you can change the field that you want to go to. You can change the project. You can change the well that you're accessing. And you can also change the scenarios by hitting the drop-down menu there. Okay, even if you want to flip through the wells, you can also hit the next well and the previous well options, the right and the left arrow towards the top right. I'll come back to this GIS map because I'm excited to show you a lot of GIS functionalities we have built into the software. I'll come down to it a few minutes from now. Let me show you all the other options that we have on the software there. So you can copy a URL by hitting that button. And then you can send that URL to any person within your company or even to support@whitson.com if you want to share any of your information, any of difficulty that you're facing. Just copy that URL. You can send a separate email to anyone. Uh, we are right now, I'm located in Houston, so I know I'm using field units, but some of my friends over here on the course, you might be located in many other places too, like Canada or any other parts of the world. You might be using a different unit system. So we have SI units and even field, combination of field and metric units that is for Canada. Even Argentina's got its own units. So I wouldn't strongly recommend you change the units for now because just to keep a consistency of what I'm showing you on the screen so that even you follow what you're doing, I would recommend you to just use field units for today. And whenever you go back, you can also flip it back to Celsius within your own domain or say SI unit system and then take it up from there, right? So, but over here for today, let's just use the field units. The next button on that is the support ticket over there on the top right. This is where you send the support tickets to all us in the Whitson. You just have to press that button and give a small description of what your problem is. It'll automatically send you the link, the URL link exactly where you are within the software so that we know we can access the same exact place in the module that you're facing the issue with, but just give a small description over there that you're facing this sort of problem. So we'll get to know and we'll tackle the problem right away. Okay. And we also built and fleshed out a lot of things on the user manual. If you can just hit that button, the question mark button to the next, it'll show you a new tab. And within that new tab, you can see all the theoretical information. Like if you go to production data analyses, and if you go to DCA section, you would see all the theoretical information, which some of them I've shown you on the slides. I've already, sent you all the slides that I'm showing you today. But if you have to access any of the other information, regarding any RTA, analytical RTA, even nodal analysis. You have all the theory based on that within the manual here. So that is pretty great. And at any point of time, later on, whenever you have access to the tool, if you want to go through the same certification steps, which we are going through today, you can also hit that button on the top left, which says certification. And within all these modules, so suppose today we are doing the order forecasting type well, everything is being shown over here in a step-by-step information of what you have to go through so that you can just access all the options within this particular module in there. So we have all of them enlisted, not just in the points over here, but also on the GIF videos. So You don't have to always call us, but we'll be pretty happy to actually take your calls to, in fact, help you out there. But we also uploaded these GIF videos for you to kind of guide you to exactly press which button and to go through which part of the module to access all of the options in the particular module there. Okay, that's the user manual. Let me come back to mass upload options. So go ahead, hit that Wells button, and within the Wells on the top right, you would see something called mass upload. So I want to talk about the mass upload, right? Because today what we did is we just uploaded some of the example wells that we have. But at any point of time, when you have access to the software and then you want to just load the data, we can load the data, the production data on the backend through API connections, or this is a front-end interface where you have multiple options that are already built in so that you can just upload the data. Let me show you these options, right? So the first thing is simple Whitson Excel template. So you hit that button there. What it'll do, it'll just open up a new tab, and there you see this Excel file has multiple different tabs in there. The first tab is basically the well header information. You just need to load well names, and well names is basically the attribute it is using to map across your well header data and your production data also. So production data is your second tab. You just give your well name over here, the time, and the production information QO, QG, and QW, and that is good enough. If you're just doing DCA auto forecasting type well, just populating your well names on the well data and production data with the well names and the time and the race information, that is good enough for us to actually start working with all the features in the modules of just the DCA auto forecasting type well. But if any point of time somebody wants to do a little more, if it's a nodal analysis or RTA and all those stuff, then you definitely would like to upload some well construction information, the wellbore deviation surveys and gas lift valves and all that thing. So we're not going to cover any of that information today, but it's just so that I'm just showing you that these are options that are available by populating the data in multiple tabs. Okay, so that was the Whitson template as the first option. There are multiple other options too. You can actually export and import the data from your favorite third-party sites like IHS Enerdeck. You have Prism data. You have drilling info. So what this is, you just can export the well headers and production data from those softwares, and you can directly import it through the front-end interface by uploading the Excel or the CSV files. Not just those databases, but you can also load information from the economics tools. People like to do economics in Aries, PhDWin, ValNav. So we've also have those options in here where you can load the forecasts from those economic tools majorly. That's from the Mosaic, PhDWin, and ValNav. But for Aries, we went a little one step ahead. And we'll probably be doing this for all the other tools too. But what we already have is if you're using Aries, you don't always need to use a backend to bring in the production data, but just by uploading the Access database. This is something new that we brought in. So just by uploading directly the Aries Access database in there, you can bring in the production data, the wellheader data, and also the forecasts. So it's automatically taking the AC dailies and the AC product information, and it's just configuring all that information over here on Whitson through the front-end interface. Previously, we only had this option where you were bringing in the forecasts, but you were doing it through a text file from the Aries. So currently, we built in this, we fleshed out this feature a little more, so you can just upload the Access database. That's easy over there. So yeah, these are multiple of these options that we have built in. So currently, today, what we just did was we just went to the examples and we used the auto forecast and type of certificate wells, and we just hit the upload button. So we have our wells populated. Okay, so that was all about mass upload. So let me quickly go through something which is my favorite. That's the GIS option. So let me pull in that. You guys also can go ahead and hit that button to the top right, which is a globe button, GIS map. And since these 20 wells, already we have the surface lat long and the bottom hole coordinates in there already populated in the well header. So we are able to see these on the GIS map too. And there are so many good functionalities that we can do through this GIS map. So let me show you a few things in here. So firstly, if you just want to do a simple exploratory data analysis, my favorite is to give it some color. So what I like to do is, there is on the bottom right over here, we have a color palette. So hit that button. That'll bring up a pop-up window, and it's going to ask us which attribute that you want to see that colored for your wells in there. So just go ahead for the production data and say oil cum. So we are trying to populate the cumulative oil for that well in different distribution bins. And what it pops up is the auto-populated ranges and auto-populated bins in there. So it's already calculating these bins. And if you don't want to do that, you can also check that box off so that you can have in your own information in your own bins that are calculated, or you just populated them. You can also reduce the number of bins that you want to populate there. You can also do multiple of these things, customize them in any way that you want to. But currently, it automatically, once you hit that button, it just automatically populates those bins and the ranges. It just hit save, and there you go. You got some color on your map. So right now we are showing you. Right now you're showing you all those wells on this, and if at any point of time you're having any difficulty, just refresh the browser, and that should see your wells in there. Or one other option is just hit reset filter. Could be that there is some kind of filter that's being applied, maybe by mistake. Just hit reset filter and that should be good to go. But yes, so this is the attributes that you're seeing. Let me also show you one more thing. So we can do a bubble map. So on the bubble map, just hit that button. That's the second button from the top right, spatial map, and choose the attribute. And I like to show the attributes. If I just have to do the same attribute, the oil cum, this time let's do a gas cum. Maybe first on the gas cum. So I'm seeing even those gas cums in the bubble map. And we also have those sticks in there, which shows you the oil cumulatives, right? So let's go ahead and close out on the oil cumulatives. You see those top X arrows and X button in there. So just close one of those. Let's close to all of those in there, right? So bubble maps and the coloring attributes. What I like to do is I like to actually see them colored based on completion metrics. Currently, we've seen through production metrics. Let's do a completion. So hit the color palette once again. Let's do true vertical depth. I like this feature there. Okay. So on the true vertical depth, I'm seeing these different colors, right? Now, why I'm showing you all these things is because it helps you to filter the wells and even group the wells based on these metrics. You can use any of those completion metrics, as we've seen production metrics, to do your grouping, and that will be very helpful eventually when you are building those different projects within the auto forecast or group forecasting. It's going to be really helpful when we see those group tags in there. So let me show you, demonstrate how exactly that is done. So now we know that we've colored these wells based on a true vertical depth. Multiple ways in which you can actually filter these wells. So the first option I'm going to show you is the lasso. So see that button, the fourth button on the bottom right, just hit that button, the lasso, and say filter down to only the lassoed wells. Okay, when I'm lassoing these wells, here we go. So all it did is it filtered down only to those 12 wells. So I'm not seeing 20, I'm seeing only 12. If I close this window, and I come back to the wells module, now I'm only seeing those 12 wells filtered down in here. Okay, so let me show you one other option. Let's go back to the GIS map, hit that glow button on the top right. Let's hit reset filter. Okay, so this time, what I want to do is I want to filter based on actually this metric rather than filtering through a lasso. Now I see the bins for that true vertical depth, and I want to filter the wells which are deeper than 12,000 feet as a condition, right? So what I would do is on the left, on the panel, you see variable over there. Let's go ahead and type in true vertical depth. Even if you say just true, it's going to show that in the drop-down menu. Just hit true vertical depth and greater than equal to 1,000 feet. Okay. Once you do this, hit the button filter on the bottom left. There we go. So we have 9 wells filtered currently, which are exactly agreeing to that particular constraint of the wells which are greater than 12,000 feet. Let's close this window. As an exercise, let's just do this. So let's check in all these wells. On the top left, you see that box. Just check in all these wells, and let's group these wells and give them a group tag. So on the top right, you see multiple of these options which you can play around with. Let's go with group as an option. And in the group, let's say group selected wells. Let's give it a name. So maybe I'm just going to give it like group 1 as the name today. So hit that button there. There we go. So we see a new column which populated over here, and the new column gives the tag, the group tag to these wells, only to these wells. How would I know that? Is let's go back to the filter. Let's go back to the GIS map. By the way, let's close this window. You can either see that filter option on the GIS map, or you can also access the same option by hitting this filter button on the top left. It's the same thing. Okay, once you go to the filter, say reset filter, and just close this window. There we go. So this time what we see is I see all the 20 wells, but only 9 of those wells are having the tag of group 1. I'll show you this functionality. So what I'm going to use is when I go to group forecasting module, that is the module to the left over here, I'm actually going to use these group of set of wells to do a roll up of my production. So once we get there, you will get to know the usability of this group tag. Well and good. Okay, so coming down the order of all the modules and everything that is set up on the left panel we have PVT production data. Let's go into the production data because we're not going to use any of the PVT. So let's go to the production data. So over here, for every well, you can actually flip through many of these wells in the drop-down menu there, but you can see multiple of these options. We are first seeing these graph template on the top, and then all the tabulated information at the bottom. Currently, what the data says is all monthly data. So you see that there is only 1 point for every month, and then you're plotting these data, right? Usually the daily data is going to be pretty noisy, but if you're talking about monthly data, it's not going to be as noisy as a daily data, right? But if you do want to do any smoothing operation, right? So some kind of because you don't want to see a few outliers in your data, you want to do a smoothing, we actually have that feature in there. So on the top right corner, you can hit the button which says smooth. And currently when it pops up the window, it's showing you the oil rate over here. I can choose that to be any other attribute as well. So currently with the oil rate, so let's say the sampling frequency maybe is just about 10 and say auto fit. So all it did was it was taking a rolling average, moving average of those 10 sampling points and is giving you one point for every of those 10 sampling points. And that's what it was doing. And it gave the yellow curve is basically the smoothed out curve. And if you want to use this curve, you can straight away go ahead and hit save. You have to check the box to the left, which is already a box that is checked for the oil rate. And then you can hit save. You're already using this curve, right? Or if you still think there is a kind of outlier in there, you see this 1 point which is slightly sticking out like a sore thumb. I want that to be almost in line with all of the data points. I'm massaging the data, by the way. You're not supposed to do that, but I'm saying there can be a use case where you want to remove a few outliers, right? So for that purpose, just go to that data point in there and you can drag it to the bottom. And you see that whole curve is automatically getting adjusted just based on the customization that you did. If you don't like that point altogether, you can just drag that point completely to the bottom of your axis, like I just did. So that point is completely removed, and the graph is connecting between the previous point and the next point. Well, you have multiple other options too for smoothing. You can do a lasso, remove points over here rather than just doing it to the cursor. Anyway, so I'm just showing you the multiple options. So just hit save for now. The moment you hit save on this window, you will see that smooth curve that is being used eventually. And this is the curve that will be using across all the modules if you use this as a feature, as the smooth curve. Let's go back to the raw data and let's not use the smooth curve for now because I just wanted to demonstrate this, that we have it in there. So let's go back to the smooth and uncheck the box for oil rate on the top left and just hit save. That way is just bringing back your raw data. So you see right now the curve, initially we started off with the same oil curve, the green curve. We're bringing in that data back again. So we're not using the smooth curve. Hopefully everyone is up to this point. Okay, so that is with the production data. Before I jump into everything related to DCA, because that's the next step that's coming in, let me talk about a few of the other things over here, right? At any point of time, like I told you, if the screen is a little smaller for you on some people might be viewing this course on a laptop or maybe on a phone also nowadays, I don't know. But I'm using a big monitor right now, so it's good for me, the zoom. But if you just have to fit in everything in one single zoom option, it's recommended to keep it 70 to 80%. That's the usual thing, so that you can see all these buttons and everything neatly spaced across in the browser. But you can also go ahead and zoom in a little more if you're having any difficulties. But 70 to 80% is what we recommend. And even you can collapse the panel towards the left if you're not using that panel all the time. If you want to see a little more of your graphs expanded, you can hit the hamburger button on the top left, and that will collapse your left panel in there. These are a few things that can help you out while working with the software. And if you see some of these buttons not being accessible to you, if I'm able to click those buttons, but if you are not able to click those buttons on your end, then you just hit Control R, or refresh button on the browser. That will just bring about the analysis once again. There are two refreshes, by the way. One is the refresh on the browser, which is placed on the top left here. That's the actual refresh. You can just use Control R for that. Or there's one more refresh that we have on the top right, which is the hard refresh. And the shortcut for that is Control Shift R. And hard refresh is something where, if we deploy any of the material, any of the new information for the module, and that's something you want to access the newest version, then you kind of use that option which says Control Refresh, Control Hard Refresh, Control Shift and R for that hard refresh. Or usually a refresh button on the browser on the top left, which is just the Control and R, will actually work in your favor. Okay. So we are good. We are almost like about 40 minutes right now. And I think we are all refreshed with looking at the software, and we are excited. We do want to click in all the buttons on all the modules. I'm also excited to show you those things, but just give me a few minutes. What I will do is I'll give you a small refresher on the modules of DCA, auto forecast, group forecasting, and even forecast manager that we built in, so that I'm giving an overview to you guys and orienting you guys to what exactly these would do. And then eventually we'll come back to the software in about a few 15 minutes down the line, and then we can play around with the whole example set. Okay, sounds like a plan. So let me share back my slides. Okay. All right, so we went through this step where we saw, okay, we figure out our domains, we have our emails and passwords. What I will do is maybe during the once I get back to the software, I'll also give a very fast refresher of what exactly I did to create my field, to create my project, and to bring in my wells, so that if anybody has missed towards the beginning of this course, they can actually follow exactly from where we've actually left out previously. So I'll just take about 1 or 2 minutes after I show you a few slides on the DCA part. Okay. So we've covered all these things on the software, and you have them also on your slides. DCA, decline curve analysis. So here's the outline we're going to talk about today. We have all of these features that is built in the software. I'm going to show you them in the slides. So hang tight. So we'll be going through all of these 6 points one at a time. Firstly, let's talk about a few things on the flow regimes. And I'll tell you, why do we need to know flow regimes? I mean, we're not doing an RTA course, right? But still, there is definitely a meaning to, in fact, opening the whole discussion by talking about flow regimes. So here's the thing, right? We heard of this term called infinite acting flow or linear flow, where your pressure transient from your well has not hit any of the boundary. That's when you see it's the flow regimes being called as infinite acting flow. That actually translates for a very, very long time. If you're having a horizontal fractured wells, it takes pretty long time to see your actually pressure transient hit any of the boundary. And the boundary dominated flow comes at a very later time, where you see the pressure trans response, which is actually hit by all the boundaries across your well, right? So that is when you see the boundary dominated comes at a pretty late time into the production history of the well. And anything in between the infinite acting and the boundary dominated flow is going to be what we call as a transitional flow. Okay, so just giving that as the spice to what exactly is the background for the DCA, there is definitely a need for us to have a mathematical equation to forecast a well, right? And what this gentleman over here, Mr. Arps, back in 1950s or 60s or so, he's built this equation. He's done his studies, he's done it, and he's given this beautiful, beautiful equation, which we call as Arps hyperbolic equation. And it's a rate function, which is a function of qi multiplied by 1 plus B AIT whole power minus 1 by B. And QI is initial rate for that well. AI is the nominal decline rate at initial time. B is a rate exponent, or we just call it as B factor. Uh, and that's how the equation is. We call it as the hyperbolic equation. Okay, and there are so many assumptions which went into constructing this equation, something on the lines of constant bottom hole pressure and also being in a boundary dominated flow. So that's the reason why I was actually giving you that small refresher, small slide overview slide in the beginning. Why do we have to learn about the boundary dominated, the flow regimes, right? So there are some assumptions which went into it, and the B factor usually should lie within 0 to 1 where this equation is applied. But what we see from our experience is definitely more than that number, more than 1 as a number for B factor. We'll talk about that in the next few slides. Okay, so just having a graphical interpretation for that equation, what we see is a B factor of 0 is actually changes to an exponential function from that hyperbolic equation. And it's a simple that's shown over here on the blue curve where the B is equal to 0. And if you take an area under the curve for the cumulatives, it's just the rate versus time, right? Once you take area, you get the cumulative. It's going to be the most conservative estimate. So that's what is exponential. And you get that when you apply B is equal to 0. Harmonic, on the other hand, is the most optimistic estimate, where with the B factor is equal to 1, it translates to this particular equation form. And overall, it's going to be, once you do the area under the curve, it's going to be highly, pretty high value, and it's going to be the most optimistic estimate also. And everything in between 0 to 1 as a B factor is going to be the hyperbolic equation. We know that. And just mathematically speaking, if B is greater than 1, we just call it beyond hyperbolic. Overall the curvature of the curve is getting more flatter and flatter, and so eventually your overall cumulative is also tending towards more towards infinite. And we have a few of these things that are built in the software, which is the limiting effective decline, which kind of tends to bring the curve a little more down towards the end part of the whole production profile. And that's what even most of the companies also do. I'll be talking about that. I don't want to jump into that section yet, but just give it a few minutes. I'll get to that part in a few minutes from now. But okay, so we got a background from Arps. He built an equation for us to help predict or forecast the production profile of a well. Now, we've seen that this is the same slide once again, where I'm just trying to show you how conservative and how optimistic that we can get on a semi-log plot. If you're just plotting them, the b is equal to 0, b is equal to 1, and b is equal to 1.8 towards the end is where you see the curvature being pretty high on that curve there. Okay, let's come down to what Mr. Fetkovich has given us, and what he tried to do is he tried to give a little more physical significance to those B parameters, so that we can understand and have a little more physical understanding of what exactly this whole equation and the behavior is, right? And so what he tried to do is, we know that the Arps equation has got its own assumptions, but B factor, through his experience, he has seen that you can tie it up with a recovery efficiency, not just on the flow regimes. B factor from 0 to 1 is more of so in the boundary dominated flow regime. And anything beyond that can actually be called as infinite acting. And that is one thing on the flow regime's physical significance. But also, let's talk about the recovery efficiency. So what Mr. Fetkovich said is, as B factor is increasing from 0 and it's tending more towards 1, you have more of the energy support in the reservoir. And in that way, you're getting a little more of your recovery efficiency within the reservoir for the production. So that's how physically he kind of tied it up with these B factors, and B is equal to 0. It can just be approximated to a single phase flow for oil, or you can also say a gas which is being produced at a very high pressure, because a gas at a very high pressure can have at a very high compressibility conditions, it almost behave like a pure liquid. So in a way, at b is equal to 0, you can just assume that to be a single phase flow. And with giving a little more energy support from the reservoir, like a solution gas drive, the B factor can be slightly more than 0, which is like 0 to 0.1 to 0.4. And slowly, when you have layered reservoirs where you have multiple support from different reservoirs, then the B factor can be a little more higher in that case. And like I told you, we are currently in Texas, Oklahoma. We have so many of these unconventional wells, and initial periods we have a lot of these fractured flow where you see only linear flow, infinite acting for a very, very long time. And these can tend to have, this behavior can tend to have a B factor much greater than 1. And we will see that even through experience too, and you might also have seen through experience that beyond hyperbolic is what kind of fits to that behavior, eventually converting it to a transitional flow where you see slightly B tending more towards 1 as a number. And when it comes down to boundary dominated flow, the B factor can be slightly less than 1. Okay, so let's talk about some of these things. How can we construct this equation and what exactly does mean, right? So let's talk about the segment types that we have. So these are the multiple options. On the top, you see the declines, the linear, constant segment type, semi-log, or the power law, and the incline. These are multiple things. Uh, uh, just the way how the equation is translated. So the first thing that we saw is a hyperbolic equation, which we just call it as a decline. And we also have programmed a linear equation in the software. So you don't have to overall just follow Arps hyperbolic equation. You can just do a simple Cartesian linear flow. Oh, by the way, it's showing a little curvature on the graph here at the back is because it's a semi-log plot I'm plotting, by the way. And a linear line on a semi-log plot will actually show you in a slight curvature. If I was plotting it on a Cartesian coordinates, then it would definitely give me a linear straight line. And then the next segment that we have in the software is a constant. We also have a semi-log. It's like an exponential function there. We have power law functions too. You can also use an incline function, which we recently built. So incline is where you use the same as hyperbolic equation, but you're using negative numbers for your decline rates and the B factor. So you're seeing a slight inclining in the behavior. Like right over here, if you have a small ramp up segment during your initial flow period, and then you start seeing a decline, then you can configure that ramp up segment using either inclines or power law. And from our experience, what we've seen is the incline majorly fits when you're doing a ratio forecasting. And when you're using GORs or water oil ratios, when you're forecasting just based on those ratios, you would see more of on the lines of power law or an incline law. Okay, so just to repeat myself, why did you see a curvature on the linear equation? That's because I was plotting it on a semi-log plot. So these are multiple instances where you can actually see a linear line on the curve, but don't be confused. That's the reason because we are actually plotting it in different ways. So the first one, we're plotting it on a linear straight line. It's on a Cartesian plot. On the second one over here, it's an exponential equation. So when you're plotting it on a semi-log plot, it will look linear on the plot. And if you're plotting a hyperbolic equation over here on a log-log scale, it's definitely going to look linear. Okay, so these are the things you have to keep in mind when you're actually having those equations and you're visualizing them on the software too. Okay, the next thing I want to talk about is the decline rate type. So on the equation over here, we saw everything regarding the B factor and the physical significance of the B factor. Now, if you just talk about the AI, which is the nominal decline rate, that is what is being called over here. And we have that as an option on the software. If you just want to play around with the nominal rates and just want to have a feel for that number, you can always switch to that nominal decline rates on the software, on the interface, and you can just play around with that, right? But we have multiple other options as well because we know that there are so many other tools out there in the industry, like economics tools and many other plotting tools which use different functions as decline rate types. So we've configured even them as well on the software. So the other things that we have is tangent effective, which is a nonlinear combination of it's just a function of an AI in a different way over here. And the secant effective decline rate is a combination of your AI and the B factor. And this just we call it as a D secant here. And I think from my knowledge, Aries is a software which uses D secant effective for your decline rates rather than nominal rates. Okay, so in our software, what we have, the default that we use is something which we call as a mixed effective. And mixed effective is nothing but a secant effective decline rate. So you see over here, we are still using a secant effective DESI, as I is nothing but an initial rate. So we're still using that. But why we are saying as mixed is because of the limiting effective decline rate. I'm going to talk about this limiting effective decline rate in the next slide, but just want to share with this information with you that in the limiting effective decline rate, we use a tangential form of it. But the actual decline rate in the hyperbolic equation, we are using a secant effective. So it's a combination of secant effective over here, the DESI, and the DE lim. from the limiting effective, that's a tangential. So this combination is what we call as mixed effective. And that's the default option in the software. You can always change that option in the drop-down menu to just keep it secant effective everywhere as well. So this is the limiting effective decline I was talking about. What it does is, for those who don't know, that I've already shown you, if you're using a harmonic equation or a hyperbolic equation with a very high B factor, right? You have this high concave upwards kind of a behavior where when you take a cumulative over the curve, it's just tending more towards infinite because your forecast is not tending more towards it's not intersecting with your x-axis anywhere, right? But for the forecast, eventually there has to be a point when you want to give it a conservative estimate towards the end of the life period of the well, when your pressure is not enough in the reservoir to support you that production. So that's why you want to build a segment which is more of an exponential, because exponential is more conservative. And that's why you kind of have this something called limiting effective decline, which from that decline rate onwards, your hyperbolic equation gets converted to exponential, where the B factor is equal to 0. So that's the whole indication or the meaning of what is delim. We just call it delim because that is the rate, the decline rate at which your equation, hyperbolic, gets converted to an exponential equation with B factor is equal to 0. And you can also see on the software, I'll show that to you once we pull up the software too, that there is a dashed line that we can just have on the graph. And the dashed vertical line will tell you exactly the transition point where your hyperbolic equation is going to be changed towards an exponential behavior. Well, there are a lot of these hotkeys that are also built on the software. I think once we get to the software, you don't always, for those people who like to use a lot of keyboard rather than just cursor. I'm a kind of cursor person, but there are so many other people who like to use a lot of keyboard in there, right? So we have all these hotkeys, so you don't have to use your mouse at all. And you can just add segments, delete segments, move your segments up and down, anything of that sort. You can do all of those functionalities just using these hotkeys on your keyboard. Okay, I think one last thing I want to discuss on the DCA part over here, the single well DCA, is ratio forecast. So I've told you that there is a particular equation that is kind of that kind of suits more towards the ratio forecasting behavior, right? So why did I say that? It's because of this person, a friend of ours, friend of Whitson, Mr. David Fulford, and what he's also recommended is this over here. That let me just click this thing here. So on the GOR, when you have the hyperbolic equation, when you take a ratio of your gas and the oil rate, and when you're just doing a ratio under the conditions where the time actually is pretty high, or the DIBT is greater than 1, all of your equation tends more towards a power law ratio. So you see that once you work through all the math, that you would see a GOR kind of translates to a format which is in the form of, CT power M, which is more like power law. So that's the reason why I was also suggesting you to use power law whenever you're using any of the forecasting, which is based on the GOR. And then I'll get to show you on the software as well how exactly that translates back to having a forecast on the primary phase, that is the gas phase. This is as an example, just by flipping that drop-down menu option on the top on the software to have it as a GOR, and you can fit your power law behavior exactly, which suits very, very well to this sort of a behavior. Finally, I think we'll show that on the software too. We have a lot of error functions where you can where it shows about the metadata on the graph, tells you what's the error in the rates and the error in the cubes that you're seeing, with respect to which is the decline forecast with respect to already the historical data that you have. And that error, when you see that the mathematical equations are these, is nothing but the root mean square error of the residuals that you're seeing between the historical data and the DCA. Alrighty, so I think I just want to leave this whole section with one small motivation slide, and that will be great for us to close this single well DCA. Our French mathematician Francis Anscombe, hopefully I'm pronouncing that right, back in 1970s, he gave a really good thought experiment, and he said that if there are these multiple different data sets and you're plotting them, these data sets, but assume they are having same mean, variance, regression lines, correlation, all the statistical information, right? People who are really good data scientists, they want to view all the historical histogram information and summarize them through these statistical information. If you see that all these plots, by the way, even though they look a little different on the graphs, they actually have a similar statistical background information. Isn't that strange? So, which means to say that there is a lot of value in actually plotting these data on graphs and understanding the whole behavior rather than just having a simple observation of looking at the summary statistics. And that's even the motivation and a principle that we kind of followed within the whole software. So on all our modules, whatever you see, it's always good to have a plot and a graph on the module. And even for your experience as well, if you just go about working through all the examples, it's definitely great to have a feel for the whole data by looking at the graph rather than just looking at the numbers. And that's the kind of principle that we kind of upheld on the software, and you'll see that once we pull up the software. Uh, Okay, so before I pull the slides, what I will do is I'll quickly go through these other three different modules, which are all completely based on the DCA, by the way. So rather than, it's actually good to show these modules on the software rather than me speaking of these modules. But I'll just give you a few overview of what these are, so that you get to know we are going to actually be talking about these things and showing you these things on the software too. So these are auto forecast, forecast manager, and group forecasting, which are all based on DCA, by the way. Okay, so firstly, let's talk about the auto forecast. Why do we do auto forecasting, right? So we can ask the software, by the way, to do a single well decline fit by itself rather than we manually fitting these things. We can do that. And we can also do something where we ask the software to do a decline curve analysis fit on multiple of these wells at the same time. And isn't that cool? By the way, a lot of these banks and all these people in the PE firms and A&D firms and A&D structuring, what they do is they would get usually 2 or 3 days of a time during a weekend, and they have to evaluate the whole performance of a field just by doing this simple exercise where you have these 10,000 wells or so, and you just have to build decline curves on all of them. And just imagine what that plight would be if you're just manually fitting the DCA on all of those wells, right? Big nightmare. So just to avoid that, what we have is an auto forecast functionality in the software, which will give you a kind of a very good first pass information or first draft information of a decline curve fit on all the wells in just seconds. It wouldn't take much time. Depends on the number of data that you have, but what I've seen is it wouldn't take much of a time in for the software to actually auto forecast with simple basic bounds that you configure to these wells at the same time, and it's giving you a forecast of all these wells, let's say, in just about seconds. So multiple of these other applications that we have for the auto forecast, that is, you can actually characterize uncertainty once you have the forecast built for all these wells. Because once you do your forecasting, then what it does, it helps you append your DCA to all your existing historical data. And then you'll also see that in the type well module. Once we build the type well, you can characterize the uncertainty of a type well by having a P10 over P90 ratio, and that will let you do all sorts of uncertainty analysis. And you can also, the other applications of auto forecast is once you do your manual forecast, you can validate all that information by having an auto forecast thing as well. So anyways, there are multiple of these things. And in the software, what we have is the three basic windows where you can actually configure these auto forecasts. The first thing is just an initialization of the bounds. You're instructing the software how you're trying to group those wells and what sort of bounds you want to apply to all the wells at the same time. And you can save all those functionalities and all those bounds as a template as well, so that whenever you come back to the project any point of time in the future, you don't have to constantly keep applying and keep reusing those bounds and manually change those bounds every time. You're losing your time, but you're actually saving those as a template, and you can just load those bounds straight away. I'll show you that in the software in a few minutes from here. And the second screen that you'll see is the auto fit screen. So just by hitting one single button, you're fitting all the wells at the same time. You can also do a QC. We have graphing options where you're seeing all the plots at the same time as well. And you can do a really quick bucketing QC information. And you can also rerun your forecasts or manually change and edits if you don't like any of the forecasts that the software has given you. You can also export the results straight away from that screen. And the last screen is the roll-up functionality, where you can actually, once you forecast all your wells, there is also an additional functionality to just have an aggregate of your forecast and see that on a graph, so that it's for QC purpose. You're seeing a roll-up of your cumulatives in the historical period and also the cumulatives in the forecast period, and see overall how is it fitting towards the expected trend that you were expecting to see. Okay, so just a few screenshots over here. That was everything regarding auto forecast. Right now, I'm talking about forecast manager. And forecast manager is once you finish your auto forecasts and save your forecast in that module, you can come back to forecast manager here and you can visualize these forecasts in multiple different ways. You can select the different saved cases as well over here. You can view them in a tabular format, in a graphical format, and even statistical format. So graphical format, this is how it's going to look like, and we call it as a bulk view option. And statistical format is where you can build cumulative distribution functions and even probit plots for all the different functionalities of the EOR or even segment parameters. I think it's better to show all of these functionalities in the software rather than me just giving you everything about the information on a slide here. So that will be pretty cool. Finally, the module is the group forecasting module. Well, I've talked to you about roll-up function, right? So in the auto forecast, once you finish off all your forecasts, you're rolling up all your production. Pretty good, right? But what if you want to do a forecast on the rolled up volumes? And I think that's also a good application where some people like production engineers on the field at the manifold level, they just want to roll up the whole production for the number of set of wells that are going into a manifold. And then they want to create another forecast on top of that with some additional cutoff for the whole group. And I think that's a really good use application for this sort of module where you're rolling up initially and you're also doing a forecast on your rolled up volumes. And we'll go through that and when I'm showing you the software as well. Okay, we're not going into Typewell right now, but let's fire up the software back once again and let's do a few exercises in the next 45 minutes, and then we can take a few minutes break afterwards before we move into Typewell section. But my goal right now is actually to do the single well DCA, auto forecast, forecast manager, and also the group forecasting modules, a few examples in the next 45 minutes. So let's go ahead, come back to the software. I hope everyone's following along with me over here until this point. Like I mentioned, I said I'll just give you a quick overview if somebody has missed the part in the beginning of our presentation, like how you're going to create your own field in the project. So let me just quickly show you that. In the browser, just hit courses.whitson.com, and within the field section, go to the field which says DCA course, May 2026, that's today's course. And once you're in the course, just hit the add project button there on the top right. Create your project by your own name. So that's what I did. I created my project by the name of Sri and just gave it today's date, 5/7. And within that project, you would, once you get into the project, you would see a blank slate, nothing in there. So the motive is for us to load our wells into this project, right? So go ahead and hit mass upload. Not everyone, the people who haven't followed, I'm only asking them to actually follow these steps. So in the mass upload over there in the example section, just hit that button which says auto forecast and type wells on the blue over there, and just hit upload button on the auto forecast and type well certificate wells, and then you would see your 20 wells populated in your project. So for the people who have missed the beginning part of the course, I'm just repeating the steps again. Create your own project, which is add a project. You get into your project and then hit the button mass upload, then examples, then use this auto forecast type well certificate wells and hit upload over there, the blue button. Okay. Alrighty. So let's get into DCA. So on the module, let's hit that button on the top left, which says DCA module. Okay, on this tool here, on the interface, what we are seeing, there's so many of these functionalities. It's a single well DCA, by the way. We are not talking about multiple wells at the same time. So currently, let's just look into how you can configure your DCA just for one single well, because that will be a really good fundamental for us going forward when we are doing DCA for multiple wells at the same time. So what we see on this interface is on the top, we see three different tabs, one for the oil, one for the gas, and one for the water. By the way, we don't have any water rates on this data set, so we only have oil and the gas. So currently, let's come back and flip back to the first tab that says oil. So we have two plots over here, the top plot, which we call as a primary plot, and the one at the bottom we call as secondary plot. And primary plot is where you see the actual historical data. And right now it's for the oil phase, you see everything in the green color. And the DCA, which is overlying on top of your historical data, is the black line. And everything that we do with changing the parameters for that black line, that changes the whole DCA parameters, right? That's the one on the left panel over here. And everything with regards to B factors, if it's a hyperbolic equation, it's B factor, QI, QF, decline rate. They're all mentioned right over here. And the start point, the end point for when your DCA has to fit. Everything you can just configure on the left section over here on the input panel. Okay, so let's go through some of these things slowly one at a time. So I'll start off with a few of these options on the left over here. So what we call as the current case, you see this main over here. So everything that you're going to make changes to any of the parameters on the DCA, they're all being automatically overwritten to a case. So you don't have to save, so you don't have to press any button which says save, because you can see on the software, we don't have anything which says save case, right? Because you're already starting off with one case and everything that you do is being overwritten on that case. So currently, let's just play around with the main case. And over here on the decline curve rate types, I mentioned to you on the slide as well, we are just using a mixed effective as a decline rate. So when I say mixed effective, all it means to say is the AI or the nominal rate is being shown as a secant effective decline rate, which is the initial secant effective decline rate over here, the DESI. But the tangential effective decline rate, which is the limiting, is being shown over here at the bottom. That is in the tangent, by the way. The limiting effective is tangent. And the decline rate, the initial decline rate, is actually in the secant. That is what is a mixed effective. If you change that function to secant effective as a decline rate, you see both of them change to secant effective. For now, just keep it to default. Let's go back to the mixed effective. Okay, so the other numbers that you see over here, the EUR, the NP, everything is corresponding to the data that you have. NP is basically the cumulative of your production data, and that actually there is a small dependence of that number that you're seeing with the last endpoint over here on the graph, and I'll be talking about that in a few seconds from here too. But just remember that what you see over there, NP is basically the cumulative data, EUR is the overall EUR with the historical data and the forecast data. So, and RR is the remaining reserve, which is the NP plus the remaining reserve is actually going to be your EUR. So it's just a summation of these two that's is going to give you a EUR, and it depends on the way you're structuring your DCA too. Okay, so for the segment types, you have multiple of these types over here. By default, we show you an Arps hyperbolic modified Arps equation, and then you have these multiple other functionalities in there too. You have the B factors, QI, QF, decline rates, and all these other things that I spoke to you about. Okay, let's come back to the primary plot and see what options do we have on the primary plot, right? So on the top, you see something called the forecast type as a primary. And if you can flip the options on the drop-down menu, you can also change that to any of the ratios. And it's going to ask you whether you want to fit that ratio. Currently, let's just say no, because I'm going to show this functionality in a few seconds from here again when we go to a gas tab. But just hit no there so that you know that your forecast type is actually primary on the oil phase. So that's what it means. Okay, you can change the axes options. You can either toggle them on and off to keep them to be either logarithmic or non-logarithmic. You can also plot them based on the rates or the days on the x-axis, or you can also have them by month and also on the days. A quick reminder, I see some of you are actually accessing some of the things on my project. It's okay for you to view into my project, but I would strongly recommend you create your own project in the beginning, like I showed you, and you upload your wells and just follow all the steps that I'm doing in your own project. And that's a really good, strong recommendation that I'm giving you. Okay, no worries. So what we'll do, let me show you all the other options that I have over here, right? So people might even prefer to do DCA not only on the rate versus time, but also on the rate versus Q axis. And that's what we have this option there too. Once you toggle that switch on for the rate Q, you have this option there, and all those things that you change on the left panel, you can also have those configured on the rate versus Q visualization too. Okay, so what else do we have over here to the top right? We have a limiting effective decline. So you hit that button, the vertical button over there on the top, that'll show you where exactly is the point that your hyperbolic equation is being modified into an exponential behavior. So that's the whole meaning of a modified Arps equation. Okay, so that's the limiting effective decline. And you can see that also as you hover your cursor on the curve there, once you move past that vertical line, your decline rate is actually being constant, and your B factor would be 0 from that point onwards. Well, there are some other functionalities like you can hit the hotkeys and you can just play around with those hotkeys. Let me show you a few things on the graph, by the way, and I can come back to those other key options that we have. So firstly, if you just have to zoom into any portion of your graph, you can just click and drag on your curve. That'll kind of zoom into your curve. So you can see a little more in the in-depth zoomed in view. If you, at any point of time, you just want to come out of that zoom view, just double click. Double click on the graph. It'll just get you out of that zoomed in view. If you're having difficulties in clicking, in double clicking, sometimes that might happen if you're using a laptop, because I've seen that I had that issue too at some point of time. You can also hit the button which says reset zoom on the top right. So let me just show you that. If you just zoom into the scale over here and you hit that button reset zoom, just resets you back, give you a zoomed out version. Okay, if you know your axes numbers that you want to see or zoom into, you can also change and scale your axis by just going to the corner of your x-axis over there, and you can just give a single click and it'll pop up that blue marked highlighted region there, and you can just give any number. Suppose if I'm saying 4,000, and even the same thing on the y-axis, if I just go and click towards the corner there and just say, hey, scale it down only to 500, I can make all of those changes in there by just giving that number. Or all I can do also is once you hover your mouse to the end of that axis, then you have a two double-sided arrow cursor. It's transformed in a two-arrowed version there, and that you can just use to just drag your x-axis left and right, both on the y-axis and also on the x-axis. Okay, there's also a secret option, by the way. This is something which is only since you have registered to this course, you're pretty much private to this information. It's like a secret menu that you find on some of those restaurants, like in and out menu, which nobody talks about, but it's only through word of mouth you get this publicity information out. So this is what I'm going to give you. Exclusive information is once you go to the corner of your graph, you hit a shift button, and then when you're dragging along, after hitting shift, once you go to that corner, it's auto scaling both your X and Y axis at the same time. And that's an option which we didn't have as a button, but we just want to keep it a little more secret for heavy end users, if you want to have a little more customization options in there. Okay, that's cool. So let's reset the zoom back to where we wanted to see with the whole curve in. And at any point of time, if you feel that graph is actually pretty small for you to work with, you can also maximize your screen by expanding, by using that button which says expand on the top right, which will let you completely populate your whole screen with just that particular graph. And you can see a little more in-depth information in there. You can add your production comments to at any point of time when you see, okay, you can just hit that button on the top right, and you can just, the comments even that you add in the production data module, not just on this module, the production data module can be shown over here and crossed over onto other modules as well. So since I didn't have any comment previously, suppose if I just say comment number 1, on this particular point, it'll show me as a yellow line, and when I hover my mouse over there, it'll show me even the comment as well. Or I can just hide my comments in there. Just hit that button once again, show comments or hide comments, either to see or not see those comments in there. Okay, so let's talk a little about my DCA. How do I actually configure DCA on the graph? Because I spoke to you about changing those options on numbers on the x-axis, right? On the input panel towards the left. Because it's simple. Whenever you change your QI to any number that you want to, if it's 300, the same number is also being changed. If I change my B factor to something like 0.5, you see that black curve automatically being changed on the graph, right? So you can have all of those things. You can even lock the function there for the B factor, and you can ask the software, by the way, to fit the whole curve by itself. Let me show you how. So right now I'm saying B factor of 0.5, right? But it's still not a great fit. So I lock that B factor there, hit that button which says auto fit in the top left, and there we go. What it did is it regressed on the other parameters like the QF and the initial decline rate by keeping that same constraint as the B factor, and the software automatically fit the whole thing curve for me rather than me manually changing it. So that's one of those cool things that we have in there. Uh, and we can do a little more functionalities if you're more of a graphical user. You see those three endpoints on your black curve, right? And there are some functionalities that we built into it. So go ahead first, unlock your B factor. And once you unlock it, let's just play around with those three endpoints on the DCA. So if you just drag your last endpoint and move it up and down, you see all it's doing is it's changing your the QF point and your decline rate, right? Once you also change this over here, your initial point is changing your QI and the decline rate. If you're moving your middle point, it's actually changing B factors, the QF, the decline rate, a lot of other parameters too, right? So there's a lot of things happening. If you don't want all of those things to be changed, but if you only want to change the curvature of your curve, I would strongly recommend to hit that button on the top, which says adjust the shape of the decline curve. So go ahead, hit that button there, and then start moving with your middle data point there. That lets you only adjust the curvature of the curve. Okay, but if you want to change the point of curvature from where you want to change the curvature of the curve or the shape of the curve, then you can go ahead and hit that other horizontal double-sided arrow on the top right, and that'll slide that middle point up and down on your DCA curve. And then when you hit that other button, adjust the shape, it'll adjust the shape from that point of curvature onwards. And there are some cool hotkeys for you to do the same things rather than just hitting that button on the top right. You can always hit Control. Uh, if you hit Control and then just move your middle point, it's actually changing the shape of the curve. But if you hit Shift and then slide along the DCA on the middle point, it's just sliding that point, release the shift, hit Control again, and then drag it up and down. That's when it's changing the shape. So a lot of these functionalities with the control option and with the shift option, if you want to go through them by yourself and just play around with the whole tool, we have these, just hit that keyboard button on the top, which just opens up a new window for the hotkeys. And then you have all of these ways in which you can change and edit those segment parameters on the hotkeys option. Okay, so all good on that. Let me also show you some really interesting things. I talked to you about the auto fit option, right? The button that you press on the top left. But some people, a little more additional things. If you just want to play around with the graphical data in there, you can hit this button called Fit Options, which looks like a lasso. Hit that button there, and you have a spray gun fit right now. Because this is something that you can use if you don't want the software to actually fit all of your data. If you only want to fit to a particular section of the data that you know of, you can just hit that button there which says spray gun fit. And once you spray your data points and you release your mouse, it's overall the auto fit is actually working only to that particular data points rather than towards the whole history. By the way, you can change that information as well by configuring your start date and the end date on your DCA at any point of time on the left info panel. But this is what I'm showing you as an option that we have on the graphical user interface. If I go back and just hit auto fit, it's automatically going to fit through the whole data range. At any point of time, I can also lock my fits. If I just want to fit only to this region, I can lock my start point and the end point. And if I say auto fit, it's also configuring the whole equation. It's fitting only to that particular region too. So there are multiple ways in which you can do it. So release the locks on the start date and the end date and do the auto fit. It's once again fitting for the whole region. Okay, so these are some of those functionalities that we have on the primary plot, similar things also on the secondary plot here. Secondary plot gives you a comprehensive view of the forecast that you see on all the phases. So it's on the oil phase and the water phase. So these are the things. And by the way, if you want to customize your auto fit, I think that's a really good question that's asked on the chat message. Let me show you that option, right? I think I haven't shown you that. So whenever you're hitting auto fit, there are some particular ranges to which you're configuring it to. But if I have to change those ranges, then I can hit this button which says edit auto fit settings. and then I can give it specific range for the B factor. Currently, it's just defaulted to 0 to 2 as a B factor, nominal rate over here, and everything out here. The peak rate production ratio is nothing but the QI. Where should your QI be? Should it always be exactly the same value as the peak rate that you're seeing in the history data, or is it regressing towards a scale or a range of your peak rate? That's what is your peak rate production ratio. Currently, it's between 0.4 to 1.2, and so you can change these options. And so your software, if I say this 0.5 to be only 1 on the B factor, hit save. And when I'm trying to do an autofit, then we know that overall my B factor is only regressing towards this value, and it's not considering any other range. So I can change those numbers in there. Okay, so let me just go back to 0 and 2 on this. Alrighty, so I've shown you all the things on the oil phase. Let's quickly go back to the gas phase here. And on the gas phase, I can either do the same thing just by changing all those input parameters on the input panel towards the left, or I can change the way I'm forecasting my gas. We already spoke about ratio forecasting, right? So I can choose to actually have a forecast on the secondary phase. Some people like to do that. So if I just go ahead on the drop-down menu, say GOR, and hit that button which says yes. So it changes my interface, which is actually calculating the GOR. And this behavior is looking a little more like an incline, but I know from my slides that power law behavior fits a little more better for a ratio forecast. So I went ahead into the segment type, I changed it to power law, and let me just hit auto fit on this. And there we go. So all it did was it forecasted, it actually did a DCA on the GOR forecast, but you see on the secondary plot at the bottom, you're actually seeing a fit on the gas rate. The red curve is actually the gas rate, and that's automatically being calculated because I've given it a GOR forecast, and also I've given it an oil forecast. And how is it deciding which forecast to use, by the way? That's also a good question, right? Because it chooses the current case. It always chooses the current case. So whichever is the current case on the oil, if you're suppose creating a new case altogether, right, like a sensitivity case. So let me just do that. If you're creating a new case for oil, go ahead and say case as 1. So right now you see that if I choose the current case in the drop down menu, there is one that's called main, and there is another one which is called case 1. Choose case 1, and we can see the same option right over here at the bottom which says case 1 as the current. And then at this point, let's also play around with our curve, right? Let's maybe use a B factor of 0.3. Just lock the B factor on this one, and let's say auto fit. So the software kind of did its best to honor my B factor and also do an auto fit. But you see on the secondary plot down there, my gas, that is not actually very well, right? Even the oil forecast and the gas forecast are a little off because my GOR is actually a good fit because that's the current case. But overall, my oil forecast is not as great, right? So that's the reason why even the gas forecast is also falling off from the whole trend. So it all depends on which current case that I'm choosing. So go back to the oil phase, I flip it back to the main. You see that my gas forecast right now is actually much better. So that's the whole relation between the GOR and the primary phase forecasting when you're looking at these two things together. Okay, so I've covered a good amount of things on the single well DCA. So once I'm done with all of these configuring just for this single well, I can just repeat the same exercise for every well again and again, right? So just by flipping the right arrow, like just go into my next well, do the same exercise for all the wells, right? If there are hundreds and hundreds of wells, it'll be like a nightmarish thing for me. But we have this function where you can actually do all the edits and everything on single well DCA right over here. That's the reason why we built the auto forecast, where you can just do a forecast like auto fit settings that you just saw. You're just not doing the auto fit settings just for single well. In the auto forecast module, I'll be showing you in a few minutes, you're using those settings for all the wells at the same time. So that's the beautiful functionality when you go to the auto forecast. And the saved cases that you save over there, I'll also show that option that those saved cases will be populated over here in the single well DCA at the bottom for all the wells, so that you can access that particular case for that one well once you come back to the single well DCA. We'll do the demonstration of that, so don't worry about it. We're going to go a little slow when we get to that section. So at any point of time, when you want to compare two different cases, this is something new. For the people who have already seen Whitson, and if you're wondering if there is anything new that we've built, this is definitely the new thing that we built, right? So go into Advanced and use the Uplift Utility tab. So in the Uplift Utility, this is where you can see the differences between two cases that we built. So I know that for a base case, I'm just using as a main. And for the Uplift case over here, just using the case one. And that'll give me the EUR differences. That's the EUR for my first case, the EUR for the second case, and the yellow curve is basically the delta between those two. And it's just being shown on a log plot here, and that's why you're seeing the data only for this region because there's some negative values in there. But if you toggle off your log scale, then you would see the yellow curve being populated across the whole time zone. And similarly on the cumulative plot as well, that you see the overall on a time series basis, what's the difference in those two DCA cases that you built. So that's showing you the overall uplift that you're having in terms of different cases that you kind of build. And that's really cool. You can export the same information too. And some people like to even add a new column, which is like a dollar value to the kind of barrels that you're having on the incremental production, and just present it to your management saying, hey, this is the amount of DC dollar that I'm going to get more out of by using a different form of a DCA format. So that's the whole functionality in the use application for this uplift utility. Okay, so once you're done with this, you can also export all of this information into any daily rates, into monthly rates. You have multiple export options here. You can also just export everything as a single line summary for the whole DCA fit with all the segment parameters and everything. Just clicking that option in there will help you to export all of these things. Or if you just want to export the whole DCA into your own economic software tool, you can also use like an Aries thing, which will export you all the information in the lines that Aries actually kind of recognizes. Not just Aries, even PHDWin, ValNav, we have those options. Since I mentioned Aries, if anybody is a pretty good heavy user of Aries too, you would be happy to know that we've also built in a new module where you can see this whole interface, not in the format as you're seeing right now on the Whitson, but you can transform this into an Aries-based format, which is once you go to advanced, hit enable Aries mode, then you would see exactly in the same format as you're exporting this information to a text file. And then you can just play around with those numbers in there. And that will help you create multiple different segments or different type of segments too. So at any point of time, if I hit this button, says Control L, there are some hotkeys too. It'll explain you what are those keywords that you use. And this will make all those Aries users pretty happy. And so that this is a new feature that we built into the tool. So let's go back, uncheck this box for the Aries mode, and that will bring it back again to our Whitson mode that we have seen before. Okay. So with that, I'll conclude the single well DCA because I'm excited to show you everything on the auto forecast that I've been talking about. So let's go into auto forecast. In the auto forecast module on the top left, on the bottom left, once you hit that button, it'll bring you to the home page where you can create an auto forecast project. So let's hit that button on the top right, which says add auto forecast. Let's go ahead, do that. This is where you're clicking on and selecting the wells that you want to include in the forecast. Don't worry, because for now we just want to forecast all the wells at the same time. Sorry. So we have 20 of these wells, and we are just either uncheck and check all these wells together so that we are just using all these wells for auto forecast. Let's do that. That will straight away take us to those three screens I talked to you about, which is the initialize screen on the top, and the second screen is the auto fit screen, and then the third is the summary rollups. So let's talk about the initialize. So on the initialize, the first screen, this is where you can set the bounds for all the 20 wells at the same time. You can either change the type of the segment type over here to either constant, semi-log, power law, modified Arps equation. And there's also something new that we built, which is called transient hyperbolic, wherein you're configuring two different hyperbolic segments, like Arps segment and another Arps segment in conjunction with your initial Arps segment, and followed by a terminal or a limiting decline rate. So in a way, mostly, the operators have also seen this information that whenever you have linear flow from a horizontal fractured well, it happens for a very long time, and your B factors are somewhere greater than 1, right? So you want to configure the initial portion of your well if you want to parameterize the whole equation and the whole production behavior, then you would start off with a segment with B factor of more than 1, and then slowly transition to a transition flow, and then move into a boundary dominated flow or more exponential behavior. So that this is the functionality which helps you do that, wherein which you can, what I would do is the first segment rate for the B factor and the second segment rate B factor, I would lock, suppose if I say as 1.5 as the B factor for the first segment, would lock it right over here. And then for the second segment, I would still keep it as a range currently, which currently the range on the B factor is 0 to 2. And then eventually I would say just continue. But this is the most important aspect over here. This is the number that the software needs to know when is the transition happening from segment 1 to segment 2. And currently we just say as 365 days, like 1 year is a default. But if you know through experience that this is the period where you would actually see the end of the linear flow, and this is the information which, when you do an RTA analysis, once you do square root time plot and all those diagnostics information, then you would get to know this, where exactly is the linear flow going to end, and when you would see the transitional flow begin, right? But so if you don't have to do all of those, if you just know it through experience, then you can just give a ballpark number of where exactly the transition is happening. And the software kind of agrees to it, and it builds a 3-segmented equation for you. So 2 Arps and then 1 modified Arps exponential equation towards the end. So that is what is transient hyperbolic. It's just for information purpose. We're not doing that right now because this is also very brand new, something that we built in the last quarter. And I'm excited to show that to all the people who are already heavy end users of Whitson in there. So let's go back to our modified Arps as our default. So we are trying to fit everything to modified Arps right now. And let's talk about these bounds. So the bounds are, the way we can configure is the peak rate production ratio. So where your QI has to start for all the wells. Whether should it be exactly the same as the peak rate that you see in that well, or should it be a range of that peak rate. So currently I'm just giving it as a range from 0.4 to 1.2 of the peak rate. I'm not locking that number in there. And the decline rate also is not locked. I'm giving it a range from 0 to 99 as the secant effective initial decline rate. And the B factor, let's unlock this B factor, by the way. So let's go ahead, change that number to 1 there. And as a range, I'm just giving a B factor from 0 to 2 and asking the software to fit all these wells given that one range. And everything in the forecast down here is also that's something we can configure. That the oil cutoff rates that you have, that is something that you can also do, and you can also change how your delim rate is going to be for all your wells. Okay, so there are some other buttons that we can configure. We don't have to have the same bounds across all the phases, by the way. So we can use different bounds for different phases. So when you click that button, it opens up a new window where you're configuring different bounds for your peak rate production ratio, the decline rates, and the B factors across your oil, gas, and water. Some people might choose to actually forecast oil as a primary phase, but for the gas, they might want to choose a GOR. So in the drop-down menu there, you can also flip that option to GOR. And so automatically, the software calculates the gas declines based on the GOR forecast that it does. So we can configure it in multiple ways if we want to. Currently, just unclick back that option. So we're just keeping it default, same bounds for all the phases together. And let me show you the other option as well, right? So fit partial data. By default, the software is always fitting throughout the whole historical data, but we can also instruct the software to fit only to a particular range rather than going it through the whole historical data. So you have in the fit partial data, you can either give it as a range as a percentage from 0 to 100%, or just fit towards the last 50% of your data, ignoring all the initial data. You can just do that. Or you can exactly give it a date range that from 2024 to 2026, only fit towards the last 2 years. You're just fitting the data only to that particular date range. You can also have multiple options like first, now fit only to the first X days, or ignore the first X days, ignore the last X days, multiple of these things in there.
Sri, can you just quickly show again like how to start an auto forecast?
How to start an auto forecast?
Yeah, how to begin. Like when you get to the auto forecast, you initiate the auto forecast, and like how to set things up from the get-go. Just repeat that very quick.
Sure. Thank you for informing.
Right, thanks.
So let me show you that. On the left input panel, if your input panel is collapsed, just hit that hamburger button so that you see that input panel towards the left, and there you see the module for the auto forecast. So hit that button there. It'll show you the whole home page right now over here. And within this home page, the way it's organized is you have a typal area, by the way. Within the typal area, you can have multiple of these projects under the typal area. And so currently I created a new project which has got this default name in there, auto forecast in today's date. How did I do that? Is once you get to the screen, hit that button which says add auto forecast to the top right. There's a small button there. Just hit that button there, and that will bring this whole screen. It's a selection screen where you're selecting the wells so that you can configure your auto forecast options. So just do nothing, just say add auto forecast button towards the bottom left. It's something like a save button, right? So you're configuring your wells. So hit that add auto forecast button. Only for the people who haven't done this exercise before, just hit that button and that will straight away give you this project. So you click that project that you created on the home page, it'll bring you to this first screen. It'll bring you to this first screen, which is the initialize screen on that. At any point of time, if you still want to change the number of wells that you're using for the auto forecast, there's another quick tip I can give you is rather than going to that home page using that left button over there on the input panel, you can also use the drop-down menu on the top and you can say edit auto forecast. The moment you do that, it's exactly the same screen that you saw before. You can check or uncheck some of these wells and then just say edit auto forecast there. And it'll straight away take you to the screen, which is the initialize screen, where you can just initialize your bounds. Okay, sounds good. Let's do an auto forecast right now. So let's use all the default options. There's only one small thing that I think I missed. There are these new features that we built in. Once again, for all the heavy end users of Whitson, you'll be happy to see this, that we have a match EUR, where in which you already create a case and then you want to create one more auto forecast case exactly matching the EUR from your previous case. So the software has an additional constraint to follow that EUR, but it kind of regresses on the B factors and the decline rates to give you a match, which is exactly within the tolerance that you mentioned. The tolerance right now is defaulted to 5%, but you can change that number to anything. And the software kind of agrees to it and matches with the EUR of the previous case. That is something that we have. The new feature that we also built is use type wells for limited data. Like suppose if your well is shut in and if you don't have your well's production data in any of the phases in there, but you still want to have some kind of a number for your forecast for it to be populated in there. Because the software, whenever it has to do an auto forecast, the minimum requirement is it needs to have at least 3 data points for the auto forecast to be populated in there. If there are less than 3 data points, then there'll be no forecast provided for this auto forecast, right? So in that situation, with very limited data, if you still want to have a forecast that's built in, what you can do is you can create type well already. If it's a pre-populated type well, if you already created before, you can just use that option there, just tick that box there, and then you can just click on any of the type well that you saved. So your production profile for that one particular well with limited data is being replaced by the type well. So in a way, when you're rolling up all your production data information for all the wells and grouping together, you will still have your volumes in a way which is more representative for the whole group. So that's the new thing that we built in. Please feel free to play with that tools in there. But for now, let's go back to what we were doing. Hit reset all. If anybody has changed any of those buttons or anything in there, just hit reset all. We have a default option. Let's go ahead and hit continue. So in the continue, let's autofit all the wells. This is the second page where we come to the autofit page, and let's just hit the button which says autofit on the left. That's it. There you go. It just took about 2 or 3 seconds, I guess, for these 20 wells. And now we have all the forecasts being populated for all these 20 wells at once, and we can see them tabulated right over here. EUR in this column here, and even the error in the rates and the error in the queues also being shown on the last 2 columns towards the end. We can always press that button there, single click. It'll let you kind of order those wells on the descending order of the rates and the queues. Okay, so you can do that too. And at any point of time, you want to do a QC of these wells, so how the fit has happened. You can just click on these wells. Like I'm doing, I just clicked on the top well there. And what I would do is maybe if I don't like the fit, what the software has given me, I can just go ahead and play around with my endpoints on the graph. When I close this window, I would see a pencil button on the left here. And when I hover my mouse towards it, it'll say that it's manually fitted. So that's an indication that it's not coming directly from the software, but somebody has played around with that particular forecast. And that will be registered to that particular well too. If you want to override that manually fitted at any point of time, you can just go back to the initialize page and check the box on the top which says override manually fitted wells. So I'll just do that. I'll check that box there. I'll hit continue. And once again, I'm just going to auto fit all the wells. And there we go. We don't see that pencil mark anymore, which means to say all my wells right now are once again backtracked to whatever the software has provided to me, honoring the constraints that I've given. Okay, once we come to this stage, let's save this case. I think that'll be very useful. Let's save this as a base case. Just give it a name to it. Okay. Alrighty. So after this, let's go back to the initialize page. And after we are here in the initialize page, let's just use another case. Let's just save it as another case with a locked B factor of maybe something around 1.2. So let's use a 1.2 on the B factor, lock that number there. Okay. So I know that all of my forecasts are going to honor this particular B factor value. So let's see that. I lock it, I hit continue, I hit auto fit. I see this column for the B factor, everything says 1.2, right? By the way, this is not just for the oil. You see, if I flip it down to the other tab, it says gas. Also for the gas, it's all the same thing. Because I haven't customized different bounds for different phases, it's all the same for all the phases. Okay, sweet. So what I'll do over here is let's save this case too. That button save cases. And let's just give it a name as B is equal to 1.2. Okay. All good. So now we have saved two cases. Why we have done that is because there's so much things that we can do, so much magic that can happen once we save these cases. I'll show you those in a quick second from here. But let's just finally go to that last page that we have, which is the roll-up view. So you know the summary roll-up. Let's just hit that button there on the top. And on the current auto forecast, let's just create the new charts. What it does, it's giving me a rolled up view of my all the wells together, not just on the historical data, but also on the forecasted data. So whichever is the case that you build, suppose if you use the drop down menu on the top, if you're using a base case and creating a new chart, it's giving you the rolled up view on the rate versus time on the top and the cumulative versus time on the bottom. And you can just directly export this information into Excel or PNG format by hitting the three vertical dots on the right of the graph. Sweet. So this is how you can change and you can do a lot of functionalities on the auto forecast, but most of the magic, like I told you, happens actually on the forecast manager, on the visualization purpose. Everything related to changing and customizing these bounds, that you can do it in the auto forecast module, but let's just quickly dive into the forecast manager. Now we know that we've saved these two cases, right? So with that information, I will do is on the left input panel, hit that forecast manager button. And that shows me the screen right over here, where I'm seeing all of my information, which starts off with the well header information from all my wells in the initial columns. And as I scroll towards the right, I see everything related to the segment parameters, the D factors, the QI on the segments, the start dates on the production date, the end date, even the forecast parameters, what's the start date, what's the end date, and everything. All of these are populated right over here, and even the results. That's the major thing, right? So the results for the NP, the EUR, how much of the forecast that you've got, and everything you can see tabulated version as a first pass. When you want to see everything, first thing, if you just want to see them tabulated, this is the information for that to see. So you can flip through the cases that you're seeing. By the way, we were showing the main as the default case, but you can flip that case to base case on the top left over there, so that all the information that you're seeing right now, let's uncheck all those columns and maybe only in the well data, check just the well name, and in the results, let's just check all those things on the results. So that's the information that you're seeing only for that case. That's the base case. If you flip that option to b is equal to 1.2, which is the second case that we saved, it's just showing you all the results of the EUR and everything for that one case. At any point of time, you can just hit that column header on the EUR and just double click. Double click once, it gives you ascending order. Double click twice, it just gives you in descending order of those numbers. So it just sorts all of the data based on whatever column that you're trying to sort as a basis for. Okay, so that's one way in which you can view all this information. So let's go back to the base case as my selected forecast. And let me show you the magic right over here. We have something called bulk view. And this is, I like to see everything on the graphs rather than a tabular format, right? Like I told you before. So when you click that button which says bulk view on the top right, you can see all of these wells with the forecast at the same time. And I like to view them by 4x4 plots. So on the left, you can customize your viewing mode. So you can see all of these wells, multiple wells at the same time, how the forecasts have been for the base case. Suppose if you want to compare these wells with any other forecast that you have, like we want to compare the base case to b is equal to 1.2, I can choose the compare to case, and that will populate the base, the b is equal to 1.2 case in the dashed lines over there. So solid lines are the selected forecast, and the dashed lines are your compare to forecast. You can also see the metadata. You see in the metadata, the last row is basically the delta in the EUR, and the delta EUR is basically the delta between your two cases, which is just like that uplift potential I was showing you for single well DCA. Right now, it's showing you the data for all the wells at the same time. How much is the delta? And you can just scroll down through these wells. At any point of time, if you don't like what you're seeing, if you still want to make some edits to it, you can still hit the manual edit button, the pencil button on any of these wells, and that will quickly open up and pop up your single well, and you can make those changes to this particular DCA, and that will get registered to the saved case that you have as a selected forecast. Or, another quick functionality that we have is let's just on the compare to, let's just close this and say none. And if I just go ahead, hit shift button, and then I'm spraying across these wells, this is exactly what our spray gun fit was doing before, right? This time we're doing it on multiple wells at the same time. If I just know that I only want to fit towards the last few data points, then I can just do that by just hitting that shift button and just spraying across all these wells on the plots there. So that's something which we also built recently. Rather than just hitting this button which says fast fit, the spray can fit on individual wells. You don't have to hit that button again and again all the time. Just hit the shift button as a hotkey, and that will let you spray and fit across all the wells. Cool. Okay, let's close this window. And let's see what other options that we have for exploration, right? So we've shown you the graphical format, we've shown you the tabular format. For all the data scientist enthusiasts out there, we can also visualize these data in the form of statistics. So in the actions tab in the statistics, you can also see the same things of your forecast, the base case forecast in a cumulative distribution functions for your EUR, or you can also choose that to be any of your attributes that you have in there. So you can see the cumulative distribution functions. Let me flip that back to EUR. Okay, and you can also see the functions also for multiple different segment parameter variables that you built, the B factors, the QI, and the DESI. Or if you also want to compare between two cases like we were doing previously, so base case comparison to b is equal to 1.2, and that lets me show you for both the cases at the same time in the same plot. If this is way too much because we don't want to plot them in two different things, what I like to see is a cross plot. So we have something called a unity plot in there, which is like a cross plot, and there the EUR for b is equal to 1.2 on y1 axis, and the EUR for base case is on the x-axis. So you're seeing those variances in those two different cases that you kind of built previously, right? At this juncture, if some people want to find out any outliers, if you see that there are some of these EURs that are not exactly falling on the 45-degree line, if you were expecting them to, and if you want to just lasso a few wells and investigate what happened to these wells and why are they not following the trend that I expected, you can always click the lasso include button on the top and say lasso include, and just lasso around a few wells which you think are outliers. That will only highlight those wells. So if you close this window, you're only populating and tabulating just those three wells. So at any point of time, you can do that and hit the bulk view option, and you're only seeing those three wells in there. And you can just hit that pencil button and make those edits for individual wells as you want them to. So in a way, let me show you one small thing. On the statistics tab over here, always choose a compare to case, because previously we only had base case. Choose a compare to case. It's only then will the unity plot be populated. If you are only choosing a single case over here, by the way, your unity plot wouldn't be there because you're not doing much over there. Unity plot is like a cross plot. So compare that to a different case. That's when the unity plot will be populated. That was one of the questions that was asked on the chat window. Okay, so I'm coming out of this mode. Let me also reset the wells, by the way. So get back to the filter. You can always hit that. The two options in which you can go to that window. You can hit the filter button over there on the top of your forecast manager, or you can also use the actions button on the top and just hit statistics. But right now I'm just using the filter button and I'll just click reset. Okay, now I'm just seeing all the data points once again. Once I close this window, I see all the wells and just tabulate this information. If I just have to export all of this data as it is how I'm seeing it, I can use the export option on the top right and either just export them in the table format, PowerPoint format, or just the Excel functions that we talked about previously, right? We can have all of those things so that you can play around with them and you can build your own analysis eventually in any other platform, which I don't want you to guys to do because right now you're getting trained on Whitson, by the way. Just let us know if there's anything more that you want to see, but we have built in so many of these features in Whitson. So we're just making your life a little more easy and being helpful in that way so that you don't have to use any other tool out there. Alrighty. So one last thing before we take a short break for about 10 minutes, one last thing I want to show you is group forecasting, because I talked to you about this, right? So group forecasting is, the intent is basically, by the way, to do a roll up on the volumes and then eventually forecast on the roll up rather than creating individual forecasts and then rolling up. What all you're trying to do is do a roll up of all the volumes from historical data and then eventually creating an additional forecast on the rolled up volumes. So hit that button which says group forecasting on the left panel. That'll bring you to the same home page. And on the top right, you see a button which says Add Group Forecast. Hit that button. Uh, yes, this reminds me that I've also told you I'll be using the group that I created in the first place. You know, we were using the GIS map, and then we filtered down to a few wells based on the true vertical depth, and we created a group tag to it. So let's just do that, right? So check and uncheck, sorry, uncheck and check that box which says Group 1. So you're only selecting the wells just from the group tag. And now we see only 9 wells are being added. We can see that selected wells are only 9. Let's just say add group forecast button on the left at the bottom. Okay, so that brings me to this screen inside the group forecast project. Let's check in all my wells on the left. And that'll give me this view where on the top graph, we are looking at the rolled up volumes for the oil rate with respect to the actual time and also the cumulative oil with respect to the actual dates that you see. Okay, we also see the well count also in there. This is all from the historical data. So when we hit that settings tab on the top left, so this is the first tab, by the way. Let's go ahead and hit the settings tab. And within the settings, we can change that to either be a mean rather than a summation of all these aggregation wells. We can also make that to be a geometric mean, arithmetic mean, or just a summation, which was the default option there. Okay, we can also choose that to be normalized by any of the attributes, so that if you're just normalizing everything by a lateral length and then we are doing roll-ups, that's how it's being shown there. So currently I'm just choosing by default with no normalization. Quickly, let me show you even on the DCA tab. So on the third tab, and just go over there. Now we have rolled up all our volumes, right? So if you just want to create a forecast, just simply hit out of it. Currently, it's fitting throughout the whole history wherever it sees the peak option there. But let me pull my first endpoint and make it more aligned towards my second peak. And you see the start date option on your left panel. So just lock that option there. So that's going to lock my initial QI, the start date. And let's just say out of it. Okay. So there we go. Now we do have a forecast for the whole historical data. I mean, for the period that is from the second peak that we saw after the rolled up volumes, and then we have this overall the forecast of this. Now, if we have to apply any more constraints, we can also just go ahead and hit more constraints and say, hey, maybe my oil rate just stop the whole forecast whenever I hit an oil rate of about 5, and you see the dashed line there, that's going to give you an additional cutoff, not on the individual well, but it's all on the rolled up group forecast. That's where the whole the cutoff is being applied. Or even on the forecast end date, if you just want to end the whole thing at an earlier date, you can just change those settings in there in any way that you want. Okay, so I think this is how you can configure your group forecast if you just want to do that as an option, or individual wells forecast. You've already seen all those options in the auto forecast that I showed you previously. We are at 2 hour mark. I think I was planning to have a break at about 10:45, but since we are at 11 o'clock right now, let's take a 10-minute break. And during this 10-minute break, I'll read through a few questions. If at any questions that you have, you can just type in the chat window. Let's take a quick break and let's come back at around 11:10 Central Time over here. And after coming back, we'll do a little bit exercises on type well module. Okay, see you soon. Okay, welcome back, everyone. So it's about 10 minutes past 11. We have 50 more minutes to go, and then we have a title module to actually go through the whole course. So we'll get to do that. But there was an interesting question that was asked in the chat. So I just want to repeat that by Travis. And Travis asks on the spray and fit, if you already saved any of your DCA case, then can you change any of those settings, rather than just going back to the 0 to 2 all the time in the auto fit, can you change that to something else? So that's a really good question. Let me just quickly show you. You remember we saved a case for the auto forecast. We had the base case in there, and then when you had a bulk view option in the forecast manager, by the way, uh, there is the fast fit. So I was showing you on the 4 by 4 plot when I changed that, and I was using a spray gun fit over there, right? So the spray gun is actually honoring the default settings in there. It's actually not honoring the bounds that you have initialized for that particular case. So to change that settings for the spray gun, if you're a big fan of the spray gun fit, you can always go to settings on the top here, which is the fast fit settings, and hit that button there. And there you lock in or change the B factor ranges or the decline rate ranges so that that's honored by the spray gun fit, and that will be registered to whatever case that you've already saved previously. So either if you're starting fresh, you can always create an auto forecast project where you can limit your auto forecast B factor ranges so that it every well honors to that bounds. Or once you've already saved a forecast, you can always use a spray and fit right over here. Or there's another way as well. You can always create another auto forecast case, but just have the saved case named the same way as the previous case. So it overwrites on your previous saved case with your updated bounds. So those are the three different options in which you can just kind of change already existing save cases. Cool. Okay. So let me go back to the slides. Hope everyone is refreshed. So let's go ahead and work with our typal module. All right, so the major points that we'll be covering in the type well module are some of these things. What's the importance of the type wells? What sort of biases that we have in them? And how do we go about customizing a lot of these options on normalizations and any of those multiple functionalities that we see in the software? So firstly, just the motive behind why do we need to create those type wells? Majorly, if there's a reserve section or reserves department within an operating company, they really do want to know what's your expected type well representation for a group of analog wells in an area, so that they can apply the type well to any of the budgeting things, or to any of the acquisitions that they want to do. They want to understand the whole behavior. They cannot do the forecast individually on all the wells, but they would just expect to have a representative type of behavior for the whole area. So that's one of the major purpose. So eventually, to scope out these plays, they use these type of profiles to have a characteristic behavior for that area. And even you can by differently normalizing these curves, you can actually try to find the interrelation between different completion parameters, and see how the type well is basically changing or transforming as you're having different normalizations or different groupings based on different of these completion metrics or subsurface parameters. So that's something also a typal profile can actually help you in understanding the interrelation between those parameters in there. So as I mentioned, scoping out plays, risk assessment also plays a major role. So when you have some of these uncertainty analysis that can be characterized out once you build a typal profile by appending your already existing auto forecast, that lets you have all those parameters of P10s, of P90 ratios, which lets you know how much of an uncertainty on the type well that you have, so that you can either trust this type well profile to eventually scope out the play, or you might not even trust it or try to construct it a little more further so that you can have a more representative type of profile. So you have all of those things, functionalities, once you build a TWP or a type well profile. Okay. So I've always been telling you type well profile, by the way, and I haven't been telling you type curves, right? So you might have heard this term type curves in the industry, but I'm using TWP, the type well profile. There's a difference for that, because type curves are more analytical based. which means to say conventionally people have used numerical simulations or analytical equations, and you're trying to match your production data to the analytical behaviors. That is what is a type curve. Back in those days, people used to use those transparent sheets in there and just overlay your production data on top of that, like Fedkovich curves. Those are type curves. But that is not what we are doing in the module here with the typal profile. Typal profile is just an aggregation of all your analog well sets so that you're just getting one simple representative curve, which is a representation of that associated wells. So that is just the simple representation for the type well, and that's what we call it. This is just how it is on the left. It's a type curve, but on our software, we always have it as type well. Okay, so what sort of aggregation things that you have in here, right? A typal can be a representation of an arithmetic mean across the whole time scale of your analog wells. But arithmetic mean can always sometimes, if you have high amount of outliers in your production data, then you're biasing your overall typal profile based on those outliers. So arithmetic mean might not be applied to you, especially for those cases where you have only very, very few number of analog well sets, like about 5 or 10 or 20, all those that can be susceptible to all those outliers. So that's not a great option all the time. Similarly, even geometric mean is more susceptible to skewness in more on the lower values. That's what people have seen mathematically. But what is recommended is more of a P50 as a typal metric, and even SPEE monograph. Once you get into that document, you will see a lot of things in there which talks to you about how P50 is a little more better match based on the data that you have. But on our conversations with the monograph team as well, they would say P50 is kind of more of a recommended metric to have a central tendency or an aggregate for the whole representation of your analog well set. So in our software, by default, we always show P50, but you can always change that to any other option in the software too. I'll show you that once we get into the software. So multiple different graphs, what you see on the typal profile. I'm just showing you some of these snippets in here. We can have them typal on the rate versus time scale, or we can also have them on the Q versus time. Some people like to do it on the rate versus Q. So we also have that as an option. And then eventually you're clubbing all those things together on a plot, which is more of a statistical orientation. And that is what we call as a probit plot. And probit plot is nothing but it's some kind of where you're understanding the P10s and the P50s and the P90s uncertainties on those ranges for any of the metric that you choose. And suppose in this point over here in this graph, we are choosing the IP60 as a variable, and it's just giving you the overall the ranges for these cumulative distribution functions on a probability scale, where exactly the EUR, the IP60 kind of lies across your the whole time periods of all these wells. Just on a similar basis, the probit plot is always something what we show on the software, and we give all the statistical information for you to characterize the uncertainty of the data because this is depending on the group of the wells that you choose. The black line is basically an approximation line. The black line is a log normal approximation of your sample space of the wells or the analog wells that you're choosing, and the tendency is the EUR of any of the well is actually more tending towards a log normal distribution when you're plotting it on a probability scale. And so that's why you're comparing your statistics with a log normal distribution over here if you're talking about EUR. And so we show the uncertainty of your actual sample space with respect to an approximation to a log normal. And this is something which people do understand when you're trying to build the typals. You can export all of this information as it is with the statistical data from the software. Once I get to that part, I'll show you all the options on the tool. Okay, so I spoke to you about normalizations in the beginning, right? So I said, we can normalize our y-axis and x-axis in multiple different ways. So let me just show you that. So on the time scale, if you're just plotting your rate versus time curves, then you can always normalize them, all your analog well sets to exactly at time t is equal to 0 when they started flowing. Or you can also align all of your wells at the peak rates of wherever they are, and then start your production right from the peak rates. And when you're creating a representative typal profile, considering QI to be one of those peak rates in there. So that is something as a different option that you have for time normalization. Or on the y-axis, if you're concerned about y-axis on the rates, you can also normalize them by a dimensional quantity like a completion parameter, lateral length, any of the production parameter too. Or you can also create your own attribute, by the way, through some mathematical equations. So in our software can actually let you do that, where you're creating your own multiplications or linear or non-linear functions of different variables, and you can have that attribute as a scaling factor to be applied as a normalization for your y-axis. So that is also extremely possible. If you're using a lateral length, which is the default, by the way, on the software, you can always change that option. I'll show you that. If you're choosing a lateral length, sometimes there are ways in which you don't always have a constant sort of the normalization for the lateral length. Like it can also be a linear kind of an equation for lateral length, which is what you kind of want to normalize to, or even a non-linear format of lateral length, right? So sometimes if you have normalized your typos by 5,000 feet, but sometimes uh, if your well has lateral length of 5,000 feet, my mistake, sorry, but if you're normalizing it to 10,000 feet, then you don't always get to have two times of your rate, but there can be a slightly a different scaling aspect also on the rate, right? So you can have those functionalities in there too by having a non-linear scaling on the lateral length when you're normalizing your y-axis. So we can have customized over there, not just by constant lateral length or something, but you can also have functions of the lateral length. So I'll be showing you that also on the software. Okay, this is just the representation of what I showed you on the time normalization. You can, on the first over here, the graph is you're normalizing by all the plots at t is equal to 0. As you can see, all of them start exactly at t is equal to 0. On the right plot over here, you can see all of the analog well sets are actually aligned at t is equal to 0, but that is where the alignment happens at the peak rates. So that is how the alignment takes place. And so the green curve with the P50 curve, the average curve, by the way, is actually starting off exactly at that point where the peak rates are aligned. There are multiple other options also that we recently built in the software where you're doing a combination of those two, combination of both. Where you're aligning by the peak rate and also shifting all of the curves to t is equal to 0. So that's also possible in the software. And there are some strengths and weaknesses of both these tools in there. So if you're aligning by first production, that is t is equal to 0, then you're actually honoring the whole of the production data. So everything, if you just want to parameterize all the flow behavior, the initial ramp behavior, and also the following decline behavior, you're capturing all of those things. So that's a major strength in there for the time alignment on the first production. But if you're aligning only by the peak rate, then you know that your decline is going to, there's a single decline, and that might honor your whole profile really well, but there are some portion of the curve that you're kind of missing when you're representing it through the type fill. So that's the only weakness or the drawback when you have it when you're aligning by the peak rate. So it's just like a judgment call of how you want to use the methodology to create your type fill profiles. And you have these multiple options in software too, where you're normalizing based on the lateral length, non-lateral length. I already showed you that. You can also normalize them by the flowing time. So if you have the downtime somewhere in there, if you're shutting down a few or some of these wells, then if you're plotting them on the time basis, then you can also have them plotted by the flowing time rather than just the actual real time. Okay, so this is another thing that we want to talk about is the survivor bias. So when you're doing a typal profile, you see some of these wells as an example that the production of these wells is actually stopping right at the point of about 15 months or so, right? And you don't have production of these wells anywhere down the line. But when you're doing an averaging operation of these type wells, the red curve, it's actually giving you a high value even to the end, up to about 60 months or so, even though you know that there are only two wells that are operating during that time, right? So what it's doing is the type well is getting more biased towards the wells that have survived over the longer period. This might not be a completely representation, like a true representation of the behavior of a reservoir. So in a way, so we have built in a software options to check in and check out of the thing where you kind of can include the survivor bias or not even include the survivor bias. But let me just show you as an example. So on the left over here, we're trying to include the survivor bias. So that means to say the wells are actually showing, are being a little more biased profile towards the wells that are surviving over here. But on the right, there's the option, if you uncheck the option, if you're not including those producing wells in the averaging calculation, that's when we are handling the survivor bias a little more better. What it's doing is, it's just giving a weightage factor. So the producing wells will have a weightage factor of 1, and the non-producing wells will have a weightage factor of 0. But when you're doing an averaging computation, then you're also considering all of them in the average of that production rate at every time step. So that's why you're seeing a more representative behavior of the typal profile, even as your well count is dropping down. And you can change those options. You can just check and uncheck these boxes in the software to handle the survival bias. Okay, so we'll see this as an example too in the software. As we go through the example data set, what I'm trying to do is these two operations, uh, which is what I call as a forecast, the average and averaging the forecast, right? And just intuitively, just to tell you, what it means to say is, if you have your historical data for all your wells, you can just do an aggregate and create a typal profile just based on the historical data, which could just be about 5 years or so, right? And then you can create a forecast on the aggregated information. So that is just called forecasting the average, which is the curve on the left over here. Okay. But the curve on the right is an additional functionality that you get when you actually use the auto forecast module. Because you guys remember in the auto forecast, we've done the forecasting automatically for all the wells rather than just going them one by one every well at the same time by doing it manually. So we just actually did an auto fit function. So within seconds, we could get the whole decline behavior. And then when you append the decline behavior of all these wells to all the existing wells, and then you're taking an averaging. So all you're doing is you already create a typal profile based on existing forecast for all these wells. So in a way, when you only do eventually you parameterize this curve at the end, all you're doing is just averaging the forecasts, right? So that's the whole operation there. You finish your forecast first, and then you're just doing an average rather than doing the other way around, where you're just creating a forecast. You're creating the average first, and then you're forecasting on the average that is towards the left over here. So we'll do exactly these two operations when we're doing our functionalities in the software, and then we'll go through an example data set. We can actually view some of the uncertainty parameters of plus 10%, minus 10% by configuring multiple of these things in there just for viewing purposes within the software too. So when we go ahead into the tool in about a few seconds from now, the whole workflow we're trying to follow is these three simple steps. Number one, choose the well set that we want to create the typals profiles. And then the second is choose the settings on that. What sort of normalizations that you want to use and what sort of coloring attributes that you want to use eventually. Do you want to append your DCA, do not append a DCA? And towards the end, we are going to parameterize the typal profile. So that's the whole workflow in the three simple steps that we're going to follow. And at the end of the exercise, the goal is basically once you finish your typal profile creations, you want to assign these typal profiles to individual wells so that these typal profiles can be as a guiding tool or a reference tool for you to create additional DCA or additional forecast for any of these wells on the basis of the typal profile. So we have a function which exactly does that, where you're bulk assigning these type wells to individual wells. And when we go to single well DCA, we can see the visualization of the type well in the single well DCA module. So that will be easy for us to follow right in there. Okay. With that, let's dive into the software. So let me minimize this window, pull up my software once again. And we're just working through the same data set, by the way. We have our wells that are uploaded. So I hope that everyone is able to see my screen. What we will do is we will hit the button which says Type Well on the left. Okay, so on the Type Well right over here, let me talk to you about the organization once again, right? Maybe I was a little quick previously, but you can create different Type Well areas. And this is more relevant in this particular Type Well section over here, where you're creating multiple different typal areas, and you can select the number of wells or select different well sets for each typal area, and you can name different projects under these each typal area. So currently right now what we have is just the main as a typal area, and under this, if you just click and unclick, you will see that there is only one single project. It says main as a typal project, right? What we will do is let's go ahead and create one more typal project. So on the top right, say the button add typal project, let's just hit that. Okay. And within that, let's just keep selected all the wells. We're just choosing all the 20 wells again and hit the button which says add typal project towards the bottom left. Okay. So once again, what I'll do is I'll go back to the home page just to show you what exactly that we did. So I went to the home page once again on the type well. You can see that now in the type well area section, we have two different projects. One is the main, which is the default already there, and one which is the project that we just recently created. Okay, so which has a well count also as a 20 number, and that's the project we are dealing with right now. So go ahead, click that project. That will take you to your first page here. Okay, so on the first page, let's check in all the wells. So we have 20 of the wells. Right. So what it does is it populates my main primary graph over here. And this, I like to call it as a spaghetti plot. And what it means to say is we have all our associated wells in the background. They are grayed out right now. And the case that we're trying to show, the central tendency metric that we're trying to show on the aggregation is the P50. Okay. What we can do is just single click on that P50 on the legend bar, and that completely takes it off away. Now just click P50, sorry, P10, P50, and P90 again. So you're able to visualize them just on single clicks. You're able to visualize all of those. You're also able to visualize the arithmetic mean, Swanson's mean, geometric mean, all of them on the plot. If you don't want them, just go ahead, just unclick them, and just keep the P50. So we are going to deal mostly with the P50 case right now. So you'll have the P50 curve right there, over there on the graph, and that'll be easy for us to visualize, right? And the related properties of all those wells, you can see them at the bottom. So at any point of time, when you're normalizing these curves on any of the completion metric, then you know that as a reference point, you can see all of those attributes at the bottom as well. You can customize this whole columns, what you're seeing, by pressing the customize columns over here, and you can see which graphs or which columns that you want to have them populated there. You can do multiple of these options right over there at the bottom. Okay, so what else do we see in here, right? We see a map on the top right, and I love this. I love seeing everything on a map or a graph. That's the first thing my eyes always go to. So where my wells are located, by the way, and also I see a probit plot on the top, on the bottom right, which I spoke to you about, right? So if I have to do some kind of viewing or exploration over here, what I would do is if I just have to click on any of my gray wells, the associated wells on the background on the plot, that will show me as a yellow curve in there, which is nothing but it's just highlighting that well. So when you're highlighting a well, all it's doing is if you scroll down to your well list on the left here, it's also graying out that one particular well which you highlighted. Not just that, it's also showing you as a yellow plot on the main plot over here, the spaghetti plot. And you can also see that yellowed well on the map. So you know that which well have you selected on the map house. Also on the probit plot here, you can see there's one yellow dot compared to all the other green dots. Okay, so that is something where you can highlight. If you just have to remove any of the highlight, I mean, if you just have to keep clicking any of the well, you're highlighting all the wells at the same time. If you have to remove any of the well, you know, on the top, it's a simple button where you say remove all highlights. Just hit that button and it'll just remove all the highlights that you kind of did that before for all your wells. And you know, if you have to remove all the wells, you know, some of these wells, currently there are 20 wells over here, right? It says that all is 20 and the representation on the type curve is actually 20 wells. If you want to uncheck any of these wells, you can just go ahead, simply unchecking the box there. It'll remove that well from the type profile. Or what else you can do is, you know, control and click on one of those wells on the plot there. So just a quick second there. There we go. So I think when you hit control and click, what it did was I was clicking on multiple wells there. It just took a little time, but it kind of unclicked on the wells over here. Exactly. So if you have to bring them back, you just have to check those boxes in again. But that's kind of a shortcut that you do. You can either uncheck or check those wells on left panel, or you can hit control and then click to kind of uncheck those wells from the plot itself. So that's a shortcut. Okay, let me remove my highlights. What else do we have? I can actually color these wells in multiple different ways. You know, I can color them by just the default, which is just keeping all the associated wells in the gray and the P50 case as the green. Or I can just spread the colors. So I hit that color palette, spread the colors. It's spreading the colors across on my spaghetti plot, also on the map, and also on the probit plot. or I can also color them by any specific attribute. This is usually applicable when you want to do some kind of exploration of the data analysis of how you want to normalize, what sort of well sets, on what basis that you want to group them out. So you can just do any of these things based on coloring of these metrics that will help you out in grouping these wells. Okay, all said and done, all good. So let me talk to you about a few of these normalization options, right? I showed you many of these things on the slide, but let's go through those functionalities in the software. So hit that button, which is a settings button. There's a second tab, and that brings you to different normalization options. So currently what we see is we are normalizing with respect to time. It's the oil rate versus time. On the x-axis, we can also normalize the x-axis by flowing time if we know that there is any downtime in these wells, like I mentioned to you. Or we can also do this on a rate cum basis. The button over there on the top, which says rate cum, either you can hit that button, or you can also normalize just by hitting that x-axis button, the cumulative, you can change your typal profile from a rate time to a rate cum plot. Okay, let me go back to rate time. I just want to show you the options in rate time first. And then eventually, you can choose the number of wells, the maximum number of well sets that you want to have in the typal profile. That's kind of limiting the whole data set. But even the normalization, let's talk about normalization over here, right? This is the y-axis normalization I was talking about. So as a default, we have this as lateral length, but you can also flip that option to say just none. So you're not normalizing by any of the attribute. And there are multiple of these things which we already programmed. There are something like prop and pumped, stages on the clusters, number of fractures. You can just normalize your y-axis based on that. So you're simplifying your typal profile just to that one particular metric over there, right? Which you kind of normalize to. Like I mentioned in the lateral length, I told you that sometimes it can be a non-linear scaling of the lateral length rather than just a linear scaling or so, right? So that is something which we can do by hitting the custom button. So we have a custom normalization, and you have a functionality for that. Currently, we're showing it through an equation here. The fit function can be a linear function, ax plus b, which is as a function of the lateral length over here. So it need not exactly be a constant scaling factor, but it can be a scaling factor which is a linear equation of a lateral length. Either we can choose that, or we can also choose a power law function. And you can see that function over here in the variables that you're fitting to. You can change those variables, and you can use that as your normalization factor. Okay, for now, simplicity's sakes, I'm just using lateral length. I'm just normalizing everything by 10,000 feet on the y-axis that you see. Okay, so with that, let's do the first, let's construct the first typal profile, right? So I'm excited to show you that option. So right now what we did is we just didn't do anything much, right? We kept everything as a default, and then we have the historical data in here. We have the P50 case. Remember that we only have 90 months of historical data. Cool. So let's go back to the case which we have the DCA tab in there. So let's hit that button. Okay, so once we come to the DCA tab here, we see the whole profile. The green profile is basically the P50 typal profile that we built previously on the historical data. And the black curve is the parameterized DCA curve that you're fitting on top of the typal profile. So either we can choose the green curve to be P50, or if you want to be a little more optimistic, you can keep that as a P10 case. And you see the whole green curve has shifted up to a higher value, and you can fit your parameterized DCA on top of that for that particular P10 case. But currently, let me just go to a P50. I was just showing you that there are multiple options available. For now, what I can see on this curve is the two different profiles in there, right? There's a small ramp segment in the beginning, and there's this decline factor. So if I just have to zoom into that initial ramp, and if I choose an incline as my initial segment there, and if I have to play around with this, I would just do this, right? So I would I would just double zoom out from the graph, and I would create one more, I would say add segment right at the end of that third point there. I would say add segment in there. So my first segment is actually an incline segment, and my second segment is more of like a decline segment, right? So I would just do this manually. But we've recently built a new other feature. Let me just show you that. So I'll delete the second segment. What I'll do is I'll let the autofit function just program automatically to detect these two segments, so that it's creating a multi-segmented autofit type of profile for me automatically just by clicking that one single button. Let me show you that. On the left, the autofit, hit that button, and then choose something like a semi-log plus a decline. because I think the initial RAM segment is more like a semi-log. You can also change that to any other functionality too. So what it did was it created those two segments automatically for me, segment 1 and segment 2. So I don't have to work myself to creating those segments. So isn't that cool? So I think that's pretty cool feature that we recently built. And as a really good practice, what I would suggest is always create a case first before doing any of these operations. So let's go ahead at this point of time. You know, my current case, everything what I'm doing is being overwritten to the main case. So let's go ahead and create one case first. And let's say this as, hit that button, create case, and type it as TWP1, and say that you are forecasting the average, just giving it some kind of a name to it, convention. Okay, hit save. So now you know that this type of profile is saved to that one particular case. Okay, so let's go back to the settings tab. And in the settings tab, what we will do right now is, let's append a DCA. You guys remember we already created the auto forecast where we saved the case, where we saved the, sure, somebody's asking a question for me to repeat the RAM portion. I'm just going to do that in a few seconds from here. So on for my second typal profile case, what I'll try to do is I'll append the DCA case that I've already saved, right? Let's choose base case and try to also observe what is going to happen to my spaghetti plot. So I'll use the appended base case. The moment I do that, I see all of my DCA cases appended to the historical data. Now this is more like a representative EUR that I would get only from the typal profile. The green curve right over there, that's the P50 case. So in the probit plot on the bottom corner here, I can choose an attribute which is EUR, and the probit over here right now is what is giving me as a more representative number, because right now I've appended the whole of the forecast. So it's letting me characterize the uncertainty in my typal profile because I've appended this. Previously, when I haven't appended any of the DCA, creating an EUR from the probit was not possible because that was only giving me the first 5 or 6 months, 5 years of data, right? We didn't have the overall EUR characteristic. So this would really help in a way to characterize the overall year and find the uncertainty of my typing profile. Okay, well, so all we did was we just appended the base case DCA. And to tell you a few other things on the RAM segment initially I was talking about, right? So before I show you on the DCA, what I would like to show you are these other options on normalization. So there are these 4 buttons on the top where you can set the start at the peak time so that you're aligning all of your wells to where the peak time is happening. And if I hit that button, there we go. So everything at time t is equal to 0 has the peak rates for that well. Okay, but if and you see that all the shift has happened for the production before time t is equal to 0, that is the functionality for that peak rate. Or if you just want all the plots to start at t is equal to 0, just hit that second button there. That'll help you start all these wells at t is equal to 0. Then in this case, you see the P50 curve, the green curve, it has the ramp segment, the initial ramp up segment being preserved by using this option. And that was not the case when I was using start at peak time, right? Then we were only having a t is equal to 0 where the peak is happening, so we are only having a single decline segment. I just want to have a parameterized typal profile which is more representative and realistic. So that's why I wanted to have the ramp segment in there as well. So that's the reason why I chose to start at time t is equal to 0 by hitting that second button on the top. Now I told you there's a combination of these two together which we recently built, right? This is also a new button that we recently built that is align the peaks. So all it's doing is it's aligning the peaks, it's starting at the peak, and it's also starting at t is equal to 0 by aligning the peaks. So it's a combination of these two things. Let me just hit that button there. There we go. So we see all the curves are actually being aligned at the peak rates, but also now we have that initial ramp segment also included in the profile because everything has again time shifted on the positive x-axis scale so that I can have a start at t is equal to 0. So there are different ways in which you can do the normalization. These are just some of the options that we are showing you because we had many of our clients and operators saying that, hey, we do even want to do that to preserve our initial RAM segment. Sometimes they also want to have a simplistic type of profile, just a single decline, which is when they only want to align by peak rate. So there are multiple of these things that you can do. Okay, so what I'll do is I'll just go ahead and hit that button which says start at t is equal to 0, and I'll use that to create my DCA profile. Okay, let's go back to the DCA tab. This time I know my P50 is basically coming off from the forecasts that I've appended to my historical data. So you see that green curve at the background is actually giving me the time axis all until 600 months as a time period. Previously, we had the green curve only up till 90 or so months, correct? Okay, so simply speaking, all I will do over here is, let me demonstrate that auto fit option once again, right? So go ahead, if you see the segment 2 already being there, just, oh, by the way, hmm, uh, I think, so if you're at this step right now, so just go back to what you were doing. Let me just quickly show you what happened, right? On the current case, we have a TWP1 as the average over there. So what we will do is go back to the settings and just have none over there as an option. I just want to repeat that step there. Go back to DCA. And your current case was actually your TWP with the first and the average, and just hit auto fit once again. And in the auto fit, use semi-log plus decline. So just so that you see that in the type of profile that you already created, you have a black line, which is exactly aligned with your green curve. Okay, I just repeated the step that I did before. You don't have to do that. I just saw that there's a small discrepancy in there, so I just went ahead exactly to the same step as I was doing previously, right? Okay, so if you're over here, now for the second case, what I would do is go back to settings, append your DCA as I was telling you, append your base case, and go back to the DCA tab. Now let's create our new case. So always suggested to create a case first before changing any of the parameters. So in the create case, let's choose TWP2. And this time what we are doing is called average in the forecast. Okay, so just give it as a name. And there we go. And go ahead and hit the auto fit again and just use a semi-log plus decline on the auto fit option. And now we have a slightly different number that you see for this particular forecast. I see that this is a small kind of a discrepancy towards the end. That may be because you're giving it a little more conservative estimate on the terminal decline. We can see that we can switch on that vertical dashed line. Then we can know that the exponential behavior is actually starting off a little more early. So in a way, I can change that number on the bottom here on the forecast and make that as a 5 on the limiting delim factor. Okay, yeah, I think 5 fits a little more better. So there we go. So we have this case saved over here for the TWP2, which is just the averaging on the forecast. Okay, so good to go. So on the settings tab, once again, once we go, we can visualize these two cases at the same time. So the pink and the purple color will tell you the difference between these two cases. And the green is actually the overall for the type of profile that you have it already saved, which is the P50 case on the whole, where you've appended the DCA. But the parameterized curves, the pink and the purple, are actually the ones which you created using the DCA module. So you can have them plotted on the same graph here by showing them by clicking that box which says show. You can have them viewed right up there. Okay, so with that, the only other option is that two things which I wanted to show you here very quickly. On the DCA module, once you come back over here, if you just want to create any more uncertainty cases, right, where you want to do non-linear scaling or linear scaling based on your EURs or something, so that is also something which you've already built as a new feature for some of those enthusiasts that you want to know. You can come back to your case, which is the averaging the forecast that I told you, and there is a small button, calculator button over there, and use that and say two-factor normalization. So once you hit that over here, you can create a new uncertainty typal profile case based on already the base case that you created. So currently, my EUR is showing the typal profile is showing an EUR of 248.6. Now, what if I want to create a new typal profile with a 10% increment on the EUR, but still keeping the peak rate to be the same? So I'm kind of normalizing in a two-factor different way, independent to my peak rate, but only changing the EUR. So what the algorithm does is it'll kind of change only the decline rates by keeping everything else constant, so that it's scaling it in nonlinear way, the way that I want it. Okay, so that my target EUR is also being set to 10% increment on my base case. So I saw that multiplier is 1.1 over here. That's my target EUR, and I would say create case. And maybe I would name this as typal profile 3. Hit save, and there we go. So we have a new case that is already being built, and that has an EUR of 273. I can just go to the settings tab once again, hit that show button. That will be shown on top of my other curves. Simple. So that's how I create my typal profiles in multiple different ways. I can do that for mean functions, P50 functions, geometric means, arithmetic Swanson means, and also create linear scaling or nonlinear scaling by adding that multiplier options across those windows in there. Alrighty. So similarly, you can just do the whole exercise by changing the product, by the way. We were all dealing with oil case right now, right? So on the top, you see the drop-down menu. You can actually change that to a gas. And then the moment you do that, you also have the same things. So you're repeating the process once again for the gas. So for the exercise I told you on the slides, right? What I want to do at the end is to bulk assign my typal profiles to the individual wells so that I can visualize my typal profiles on the wells production data individually, so that when I'm creating my DCA, I want my typal profiles to guide me to create the DCA case, right? That was the thing that I told you as an exercise we'll be doing while I was showing the slides. So let's just do that. Let's click typal profiles once again on the left panel. So it takes me to the home page that I have. And on the top right, you see typal manager. Just click that. So that's same thing as what we were showing as forecast manager. Previously we had a forecast manager module, which was more pertaining towards the DCA. But over here right now, we are talking of a manager for a typal profiles. So that's what we are overall trying to do. Once again, just to repeat the same process in the typal profile homepage, just hit that button which says typal manager. And there you see all the constructed type wells with respect to different phases, right? We only created for the oil phase. So that's why I see all my 3 typal profiles that I created with different case names. So either I can import typal profiles, by the way, within the typal manager. I have an import option where I can directly import typal profiles from Aries or PHDwin, Valnam, any other softwares that I built. I can just directly import them in the text format that you have from those tools. Or even the same typal profiles that you have, you can just export them right over here. You can just click it, check the typal case that I built, and just say export. And you can either export them in tabular format or even to the Aries format, which gives you a kind of a qualifier to it, and it exports to you in a text format. Okay, just to show you as an example, if I'm exporting that one particular case, if I open the file, it'll give me the notepad file for the Aries as an export option, which you can directly import into your Aries. And so you have as Whitson as the qualifier for that once you visualize in the Aries software. Okay, so for the exercise, what we were trying to do, we wanted to bulk assign the type profile, right? So let's go ahead. There's a third button which says assign. Hit that button there on the top right. So here it'll show me all my 20 wells, and all I want to do is I want to assign typal profiles to these. So I'll choose my typal to assign on the drop-down menu on the top. Let's choose the TWP3 case, which is the uncertainty, the 1.1 scalar function case for my profile. So let's just choose that. And hit that button which says assign typal to all the cases. Let's just do that. So you can see that TWP3 is populated across all the wells in the oil column. So you can choose also different phases as well. If you've created a typal profile in the gas phase, you can choose that phase over there and hit that button. It'll just populate that selective typal profile across all that phase there. Okay, so after doing this, hit the button which says assign typal to the bottom right. Okay. So it gave me a notification that it's finished bulk assigning these types. So how do we visualize them, right? That's the question. $1 million question. So let's go back to decline curve analysis module, which is our single well decline curve analysis module, right? Let's go back to it. Okay, so currently I'm showing this for one of the well, which is the 91391H. And towards the bottom, you see all the cases that we built. You remember we played around initially with something called case one, and then we built a base case b is equal to 1.2 as an auto forecast cases, right? And those cases are already auto populated over here. You can see them as saved case assigned to this one well, but this is all DCA, by the way, right? So I can have them shown or not even show them so that I can see all the different DCAs that I built. But we want to see the type well case that is assigned to this, right? So for that, go for the second tab, which is type wells. There you go. There you see the TWP3 case, and it's already saying that it's assigned. But I still don't see that on the graph, right? So just go ahead, hit the show button. And what it did is it smartly kind of rescaled it back. You guys remember when we created the typal profile, we were always normalizing the y-axis by a lateral length. So when we come back to this individual well DCA, it already considered that lateral length and it rescaled back so that we are only seeing the type well with respect to just the oil rate, and it's not a normalized rate. So that's the rescaling function that's already being done at the back end when it's assigning it to multiple of these wells. And now I can just go ahead and create a new case over there and just play around with this tool so that I'm aligning my DCA to have an initial ramp up segment and also a decline segment as I saw in the type of profile. Or I can just create any other different cases considering this type of profile as a basis for it. Okay. So you can just flip through any of the wells and you would see the same bulk assignment of the type profile. If I just go to the next well, and once again, I click the second tab on the type wells, hit show, I can see the assigned type profile for every well. And that's how you do it. That's how you kind of end the workflow where you're forecasting what everything that we've seen is we've individually forecasted these wells, and then we thought, hey, that's way too cumbersome because I have multiple of these wells at the same time, so let me just do an auto forecast. And we've done the auto forecast, we've saved the cases, and then we've used the forecast manager to kind of QC the cases, to visualize it in multiple ways in the graphs, in fast fit, spray guns, QC statistics. We've seen all those characteristics, and then we went ahead and we created a typal profile. First, we created the one which without any appending any DCA. And secondly, what we've done is also we've appended the DCA because we have done the exercise in the auto forecast module. And eventually we created a typal profile with the base case and the uncertainty case as well. And then to end it all and top of the whole workflow, we assigned the typal profile to the individual DCA cases, to the individual wells, so that be as a guiding point for us to create or edit any of the DCA that we want. So that was actually a summary of what I wanted to show you on the software and on the whole slides as well. That almost concludes everything that I wanted to show as a workflow on the software with all these modules concerning with type wells, the auto forecast, group forecasting, and the single well DCA. Hope you all like the course, and this concludes the whole course. I'm going to stay on for a few more minutes from here so that I can answer to any of the questions that you have. Just please go ahead and you can type your questions on the chat window if you have any, or if you have any of the feedback that you want to give it to us, any of the even feature suggestions that you think that can improve your whole overall experience. Just let us know in the comments. You can always send an email to us separately, by the way. I think I've already shown that to you on the slides. By the way, we are also going to send you those certifications. And for the support, you can always send an email to support@whitson.com. Any questions or any thoughts that you want to have, you want to criticize us or you want to appreciate us, any feedback is so much, very much welcome. And hope to also hear from you again at any point of time. We are just a call away. Just let us know, and then we'll be there to help you guys in any of your workflows. Thank you all for being on the call. So I'm just going to stay here for a while and just read any of your comments that you have. Take care, have a good day, and have a good rest of your week too. Yes, somebody was asking me about adjusting the incline segments. Hi, Venkat. I can show that to you on the screen share if you're still available here. Well, there is this one case right in the title profile. Right, so over here in the oil phase, not showing the profiles there. Firstly, the normalization that can be in multiple different ways where you can start at the peak rate. That is what you have right now. Everything, all your analog wells are time shifted so that they are starting off at the peak rate, in which case your T is equal to 0 is actually at the peak rate of all these wells. So when you're creating a decline curve, your decline curve is not capturing the initial part there, which has the ramp segment. So your P50 curve is actually starting off at the peak rate information. So when you're creating a DCA on top of this P50, you will only see a decline segment, right? But if you click the other button, which says start all the plots at T is equal to 0, that actually is capturing even your ramp segment there, right? And then you have the peak rates also towards the later point. So that's how you're having a shift, and that's how you're even conserving your ramp segment. Now, with this option, if you go to DCA tab, create a new case, example, right? Uh, just let me show you real quick in there. So suppose this is the green curve is the P50 case for including the RAM segment that we had. And right now we just want to fit our DCA on top of this whole segment, right? So we just cannot have a single decline segment, but we want to have multiple segments for it to be honored. We want to have an initial incline segment, and then eventually we want to have a decline segment. It's like a two-segmented thing. So for that to happen, all you have to do is you either can do it manually by hitting the add segment here. So initially, this is your first segment. You can see that the first line is actually going high because there's an incline segment in there. And then eventually just click add segment. And so your segment one is semi-log exponential, but with a negative factor for your decline rates. You can either do that or you can also say incline. And you can have a negative B factor, negative T factor so that you're showing a small ramp up segment there. And then eventually your second plot is your decline segment, right? You can just do that. Or what I was showing was without you manually managing all these add segment and all these options, what the software itself also can do is automatically detect where the end of your ramp segment is happening, and it can automatically create the initial ramp and the decline segment. So you can do that by hitting the autofit function there and just click the button which any of the three of these custom autofits. Linear decline, semi-log, or a constant decline. Of course, it's not a constant plus decline, so it can either be a linear or a semi-log plus decline. Suppose if we do a linear plus decline, you see your segment one is configured to linear segment there on the top, and your segment two is configured to your decline segment. So you already have these two segments automatically being populated. And that's how you're parameterizing your DCA. If you don't want to see the RAM segment, let me also show you that case. On the settings tab, hit that button which says set start peak rate. You see that green curve is not capturing the RAM segment. So now if you go to DCA tab, just delete the previous segment. Now, if you see that your the green color curve, that's the historical P50, the type of profile that's created, is only starting off at that point which is aligned to all the peak rates. So if you can uh, just create a segment which is an individual, a single hyperbolic decline segment, that will be good enough to actually capture the whole type of profile for that case because you don't have any of the RAMs. So it's in a way how you want to preserve your information when you're creating that the typal profile from the analog well set, right? Whether you want it to be overall completely representative of the whole behavior in the flow regimes that you see, or you just want to have them aligned towards the peak rate and have a simplistic approximation of the typal profile. So those are the two cases that I was talking about. Okay, any questions from here on? If at all you still have any more, we are free to have more conversations with you. So please send an email to support@whitson.com, and we'll be happy to just even get on a call with you guys or even just chat with you to let you know any of the other concerns that you have. Okay. Thank you once again, everyone. Have a good day.